What did it disconnect? What? Okay. Should be better. What did it disconnect? What? Okay. Should be better. I'm hearing stuff twice. Nothing better than FDM. Okay, I should really turn that down. I'm hearing stuff twice. Nothing better than FDM. Okay, I should really turn that down. Yeah, okay, let's really turn that down. That might turn into a bit of a clusterfuck. Yeah, okay, let's really turn that down. That might turn into a bit of a clusterfuck. So we're at 10 now. Let's see how that works out. Of course, once the mill is going, we're gonna have some other issues, but... Oh shit, I lost the magnet. Shit, what up? So we're at 10 now. Let's see how that works out. Of course, once the mill is going, we're gonna have some other issues, but... Oh shit, I lost the magnet. Shit, what up? So let's just try what happens if we do this and how it echoes back. So let's just try what happens if we
Jesus needs a kin or 3 of magic rocks, salty kiss. D.
Do this and how it echoes back. So let's just try what happens if we Okay, that is too little. It's obviously not. You're not supposed to hear it twice. That is too little. Let's just try again. It's obviously not. You're not supposed to hear it twice. Let's just try again. I mean, you're not supposed to hear me. So let's see. Nothing like FDM. Where is it? I mean, you're not supposed to hear me. So let's see. Nothing like FDM. Where is it?
Keep up the great work, Tom. Best of luck with your hopefully non-headless cat.
Okay, done. Alright, but that's okay. But you're only going to hear it once. So that doesn't matter, really. That's okay. Cool, so... You're only going to hear it once. So that doesn't matter, really. So if you do... Why is this muted? Audio output, okay. Let's go over these things real quick again. So the front camera is working, the side camera is working, yes. Audio is working. I've got chat up, I've got Streamlabs tips up, I've got OBS on this screen. The overhead camera is also working. Okay. Welcome to today's day of lame puns. I actually just... Okay, today we are building and hopefully using for the first time the CNC Mill 1 V2. And like just before I started this this stream, I actually realized what a lame pun this thing is actually the name. So CNC, if you look at in the video title, you're gonna see it spilled out. I always thought they were like Italians. They were like just, you know, from Sicily or Malta or somewhere, and, you know, just had that background and audio is clicking. Great. That is awesome. Thanks for pointing that out. Great. Okay, awesome. It's just it's 100 milliseconds early or something. Let's see if I can fix this real quick. I don't know why that changes. So if I go to 250, it might be better. Sync offset. Oh, then it's going to be early than 450. Okay, let's see if that's better. Clap should be in sync now. Okay. Out of sync, not for you, whatever. Right, CNC. Should we just reboot? Just let me know if that clap was better. Good. Made it to live stream, seems good, better. Okay, perfect. So let's just act like we're starting up again, since tech is not working. Oh, welcome. Didn't see you there. So today we are unboxing the lamest pun I've ever received in a box. This is the Mill 1 V2 desktop CNC mill. It's you basically plop in this one-handed Makita router and it mills out stuff from whatever material you want it to mill from. I guess like you're not going to do hardened steel, but aluminum should be fine. But this thing is spelled CNC, S-I-E-N-C-I. I always thought that these guys were like Italian, Sicilian, something, and just, you know, wanted to bring that Italian noun if it actually meant anything. You know, wanted to use that noun. But as it turns out, I actually watched the interview of Joel, the 3D printing nerd from, what was it, Maker Faire or something, and it's supposed to be just pronounced CNC, like the what is it, computer numerical control, CNC. CNC is supposed to be pronounced CNC. So yeah, we're unboxing the CNC Mill 1. I can't see how that would cause any issues, like if you're saying, hey, I want the CNC mill. Like, which one do you want? Do you want this CNC mill or do you want the CNC mill? Again, that is why I mispronounced slicer. Slick 3R. So yeah, let's just check it out. So it's actually two different things. So this is the mill, the body, the mechanics, the motion platform basically. You don't get it with a tool head. So this thing is just a 3-axis motion system somehow. So you could slap a 3D printing head on this. It would 3D print. You can slap a one-hand router on it. It's going to route out things. It's going to mill things. So yeah, this is the base, and then you add this guy onto it. So price-wise, you have it in the title, $3.99 for the mill kit, and it's like another $100 for the tool head. Ah! Wait, is this? I'm hoping that is. Yeah, that is 2 boxes with different stuff in it. It's not 2 kits. I'm hoping. We're gonna find out. Yeah, these are 2 different packages, definitely. So nothing else in here. Got everything out. Makitas are cool. Yeah, so far only had good experiences with Makita tools. I don't know if you guys pronounce it differently, but yeah, been very happy with the tools so far. That's why I went for this one. You could get like a cheaper version of like this one-handed router. This is actually just a one-handed trim router basically. There are different options. I wanted one that was good, that didn't have any play in it. I think Makita is going to deliver on that front. Ooh, look, the box sort of lines up with the B-cam. Yeah, so I went for this. This actually goes to 30,000 RPM, which is quite a bit. That is quite a bit much, or quite a bit much. Shit. Now rated PG-13. This is actually quite a bit more than what your cordless drills or even regular drills do, etc., etc. So yeah, great for using small diameter milling bits. You need a lot of RPM to get these small mill bits to work. So hello there, congratulations on receiving your CNC Mill 1. Video and instructions on assembly along with additional resources for your CNC Mill 1 can be found on our website. So I think that's just an excuse for not including a printed manual, safety warnings and guidelines. Yeah, so don't chop up your hand. Okay. Terms of use accepted. EMF handwriting. Anti-backlash. Ooh, this one's already coming apart. Acme nut kit. Let's see where I'm going to be putting these nuts. And we're already losing a few parts. That might be some Imperial thread nut. It might also be an M3. So there's nothing in here. There's just packaging. Smart as far as printing costs go. What printing? Oh. Printing cost? We're not really printing anything today. It's a very similar it's very similar workflow because you are starting with a 3D model or with a 2D DXF file, but okay, let's hope that was an M3 because we're gonna grab another one. It's a very similar approach, and I think the 3D printing revolution, as it's often cited, did lead to a lot of things that are used here. So, yeah, don't put the nuts in the machine. Yeah, I'm those nuts I might put in the machine. Not some other ones. All right, so these are the. This webcam isn't playing along well. So these are the actual linear profiles. If you're saying, okay, this looks like some standard extruded aluminum, that's because it is. So let's get that perspective going. So that's actually what the I said perspective. That's actually what the linear guides look like. So this is a standard extruded aluminum profile. It's pretty chunky. I was expecting this to be a bit thinner. It looked smaller in the pictures. Usually it's the other way around. And basically you have open builds wheels that ride on the edges right there. So that is a pleasant surprise. All right, that's even got the labeling on there. Malaysia, aluminum Berhard Malaysia. So that's the Z-axis, and we have X and Y. Now, extruded parts, whether it's aluminum or plastic, usually have fairly good tolerances there. They're usually fairly accurate as far as just the overall dimensions go and straightness goes. If anything, there might be ever so slightly curved, but the dimensions are going to be good, and the surface usually is really good. So, yeah, if they make it work, that's going to be a very smart use of materials. So I'm thinking these are Acme, so these are imperialistic threaded rods, but they are very high pitched. They are a 4-start, so similar to what you're seeing as Z-axis in 3D printers these days. If it would actually focus, there you go. You can sort of see the 4 starts, but very high pitch. So it's going to be interesting to see how that affects backlash and how how it affects torque, linear torque, because these things basically convert linear torque. That's just force. Basically, these convert rotational torque into linear force. So a higher pitch would make for less linear force for the same torque, but a faster feed rate. So that's going to be interesting to see where that trade-off lands. If it's going to be skipping steps by just, the dynamic cutting forces, or if it's actually enough and it makes for nice, smooth, and quick. That might have been loud. Nice, smooth, and quick milling experience. So it does say anti-backlash Acme nut kits. So I'm thinking these are not an 8mm pitch or diameter. I'm thinking. This Acme typically, it might just be that Acme is like a synonym in this case for lead screws. But typically it is a synonym for Imperial lead screws. You have CAD models of these. Yes, there are CAD models of this entire thing available. I think it's even made in Onshape, I believe. So yes, the entire mill is open source. You can have a very liberal look at the parts. Yeah, it's Onshape. If my brain just doesn't completely let me down here. But yeah, the CAD files are out there, so you could. That is interesting. Okay, more on that in a second. So you can go in, you can take a look at all these parts. And maybe 3D print it yourself. These are 3D printed parts that we are unboxing here. We're going to take a closer look at those in a second. Mill 1, that's some sort of cover. Hope I can get it back together somehow. We're going to put that back together when we need it. Okay. Bolts. I'm hoping these are M8. Is it metal? The frame is MDF. That's probably what's going to be in here. But the linear guides are metal. And, wheels, standard plastic types. And yeah, 3D printed parts. You get a few metal angle brackets, of course. Screws are metal. And then you have these 3D printed parts. These look like stepper mounts. And they are probably ABS, if I had to guess. Print quality on these is pretty rough, at best. So this is the spindle mount. This basically sits on one of these aluminum profiles like this. I guess on the bottom somewhere. And then you have the mount for your spindle right there, and then an insert if you have one that is a bit smaller. You clamp it down there, and that's that. All 3D printed right there. Pretty, of course, print quality doesn't matter all that much with these parts, as long as they're functional, as long as they don't crack. And that is, yeah, that's good. Okay, I don't know what this cover does. They are open builds, wheels. I don't know if these are genuine open builds. I think the genuine ones even have the lasered bearings, so not sure about that, but a compatible system, definitely. All right. Anyone try to solder sheet metal yet? You can, to a certain extent, solder aluminum at the right temperatures. But yeah, the Google brazing, same thing, just a bit harder. That's probably what you want. All right, electronics, EMF. Joachim, thanks for the tip. Tommy should really start a TV show like helping people to get their 3D printed dialed in just perfect, including a sticker like dialed in by Tom. I offer my A8 for a poly project. Fun story. I actually got an A8 in the mail 2 days ago or so from GearBest. They finally managed to ship one out. So that's going to be interesting. I will be unboxing that thing in, well, 3 weeks or so. I'm not gonna have time to do it any earlier than that. But yeah, that would be doing a show like that, doing like a I don't know, live, probably not, doing something like that would actually mean going out to people and servicing their 3D printers basically. I don't know, sounds like a fun idea. I'll think about it. Thanks for the tip. So sheet metal use pop rivets. Ever thinking about building your own CNC? Well, isn't that what I'm doing right now? Kind of. All right. That looks like the AliExpress special. There we go. The AliExpress special CNC shield. Spelled Caesar. I don't know what N is. But yeah. Definitely, you know, with the white non-ESD foam on the back, that is definitely your AliExpress standard CNC shield. So 12 to 32 volt in. Yeah, even says down here. Standard components. I mean, I like it. Saves cost. So why not? If it works, then sure thing. 4 axes. So X, Y, Z, and I guess you could even run a 3D printer from this. X, Y, Z, and then I guess a second motor for something. X, Y, A. So a rotational axis you could even hook up to this guy. So standard Pololo drivers that are going to go in this. So you have a choice of using either Allegro, Texas Instruments, Trinamic, you name it. Anything that fits in here. And a standard Arduino Uno clone. So yeah, that is also design in Italy. That does, I don't know. Is that a genuine one? I have no idea. I think they're pretty good at cloning these. I'm not sure if this is a genuine one. It doesn't say made by Arduino anywhere or by Arduino dot whatever it is Inc. Design in Italy. So that might be or is most likely a clone. Whatever, they work. If you don't care about the Arduino project, go ahead, use them. Maybe do send Arduino that €5 tip when you download the software. I'm sure that makes up for not buying the genuine board. So yeah, parts, electronics, pretty standard stuff so far. Stepper motors, 4 pieces. Shenzhen Anycubic technology. That name rings a bell. 1.5 amp, 40 Newton centimeters. So close up of that. Anycubic, you might know them from the Anycubic Castle The Delta printer. Ooh, look at that zoom range and look at that blur. Cool. There you go. There's your motor steps. So I'm guessing these are fairly similar motors to what they're using in their Delta 3D printer. So yeah, that's that. And a few Allegro step sticks, whatever they are. Power input, you clamp that in, USB cord. All right. Hey, 3D printed SB. First mod has arrived. And we got a power supply made in China. Oh yeah, definitely made in China. Feels like it. 5 amp 24 volt, so that's going to be good for stepper drivers. If they get 24 volt, that should give them a bit more torque and hopefully less noise. Again, as usual, US power cord that goes straight in the trash. Yep, there we go. We don't use those things. Okay, let's see what else we get. Let's get these out of the way a bit. Blue smoke. Let's hope we don't get any blue smoke. All right, it looks like we, screw size wise, it is fairly. This looks a bit larger than M8, but it could be M10. This looks like it's not a lot to assemble, so I'm hopeful there. Jumpers for micro stepping. Okay. Let's see what the frame looks like. Trash recycling. Well, power cords. Okay, German recycling system is pretty good. The trash still gets combed for recyclables. It doesn't go straight to the landfill. It gets sorted and then recycled. What can be recycled, and everything else gets used for basically heating. So, and making power basically. So, right. What do we have here? We have a metal plate. That is fairly solid. I don't know where that goes. I'm thinking it might be something for an axis. That's all I can tell you. It might be the Z-axis because it makes sense to have a bit of weight there. Let's see. Yep, at 50% income tax does go somewhere, and I'm proud paying it. All right, that's another plate. For another axis, we're going to figure out where those go. And then we have some side piece. So these are half-inch, I guess, MDF parts. They look like it. They look like 12.7 millimeters to me. I don't need calipers for that, but a half-inch plywood for all these parts. And they are CNC machined as well. You can see the individual ribs. See the individual cutting lines there. So they went with a few different passes in here. Didn't mill through all the way in one pass. We get a sheet of acrylic. This camera is a bit too tight for me today. There we go, sheet of acrylic. No idea where that goes. Oh, it has a laser etched label on there. It would be nice if that lights up, if we can plop a few LEDs on the side here. So, and that looks like one of the sides, because the bottom, the base doesn't have any steppers in it. So, let's see. Thoughts on MP CNC, the mostly printed CNC? I feel like that might be a bit too weak to use productively. The problem with CNC is always, using it. So that's the front. That's where the acrylic goes. The problem with any CNC is always getting it to mill reliably requires a rigid frame. And rigid frame doesn't mean, I'm just going to use unsupported 8mm rails for everything. I don't know how large the MP CNC rails are, but they don't seem to be large enough to make for a productive mill. I mean, this is what this guy is using. and I'm expecting to be able to mill aluminum with this. And it's just these massive aluminum profiles that just, they aren't going to go anywhere. So, yeah. Chat, aluminum is going to be slow to cut. Yeah, probably. But you should be able to cut aluminum with this. So what I'm realizing is there is practically no manual included. That's all you get. That is, you know, your safety warnings and guidelines, etc. Yeah, CNC.com. That is, again, SIENCI.com/resources. So I guess let's just open it up. Depends on the spindle. Yeah, 30,000 RPM. That should be enough for pretty much everything. By the way, while I'm looking that up, how are you guys liking the new lens? I plopped a 12mm on the camera instead of the 16 I'm usually using, so the camera is a lot closer to me. I can almost touch it. Just wanted to be a bit closer and less removed. Right, so let's see what we can get here. CNC.com resources. Why do my hotkeys only work when the window is in focus? Do you spell resources differently? Oh, you do. It's only one S. Cool. It's right up here. Do I have the camera on, off? Hold on, if I press this button, that. Don't know which buttons I'm supposed to press. This one? That one? No. Okay. Bcam, whatever. I can't even show that. Okay. Machine assembly. Let's start with that. More light, didn't even notice. Okay, so this was originally, let's just talk to this one down here. So this was originally a Kickstarter, a Kickstarter project, which is why you can't, this way, which is why there's the CNC Mill V1 and the V2 right up there. So this is the V2, the new and improved one. If you back the Kickstarter, you got the V1, the one on the far side there. It looks like it's still a very similar concept. Like, I think the acrylic is new. It might be. But I guess there are a few tweaks here and there. Join our Facebook group. That seems to be like the standard go-to for anything 3D printer and CNC related. Yeah, we have a Facebook group. Job done. Where other post question and answers? Okay, let's get started. Okay, unboxing. We did that. M8. So it's Metric hardware. That's nice. Separate router box if ordered. Well, I ordered that separately. The basics of CNC. I just want to build the thing. I don't want to watch how long is that? 2 minutes. Yeah. You guys know what 3D printers are. You can figure it out, I'm sure. Next step, assembly. Can be found here. Okay, that took a while to find. Assembly manual. Okay, disclaimer, that's the same ones that we've already seen. List of parts. There you go. Now we finally get to assemble something. M38. Now where are the... Why don't my hotkeys work when the window's not in front? Yeah. Where are the M3 screws? I suppose in here. Looks like quite a small XY volume. Yes, that is correct. And I actually like that. I actually like that this machine is built in a compact fashion because, you know, again, rigidity. If you have a longer, unsupported beam that is supposed to transfer the forces from your tool head into the frame, then, you know, this thing is just going to get more floppy. This thing is going to get floppier and floppier the longer it is. So having a compact machine is going to mean better cutting quality cheaper price, and that's not linearly. That doesn't mean, you know, you build half the volume, you get half the price. No, I think it's like it's squared, cubed. So a smaller build volume is going to mean a much lower price for the same cutting quality. If you keep all the, you know, if you keep the same, well, you lose cutting quality by going up in scale and not increasing component rigidity, or you increase price massively by going up in scale and scaling up the rigidity of your parts accordingly. So I like that. You get a lot of bang for your buck, and it's not a portal router. It's not like you plop a sheet of plywood in and it's going to cut it. No, that's not what it's meant for. It's intricate parts, and for that it could be pretty nice. So little tiny M3 screws. I'm hoping we're not going to need those M3 nuts. Right. Little tiny screws right there, and that's not even the ones we need. Cool. Router, that is going to be loud. Yes, I would like to apologize to all of you in advance, because it's going to be loud. I might be getting hearing protection, just to be safe, because I do like my ears. I do like them working. Do we have 6 of these holders? Interesting. So we actually have 6 of these anti-backlash nut holes. There were 3 in this pack and 3 in this one. I see. Okay. Anycubic again. Like Anycube. That doesn't work out. So we do have that might be an upgrade part. We do have the standard nuts, the brass nuts that you use on the linear rods, on the threaded rods, lead screws. Words. These are the ones you use on the lead screws. They have the regular backlash, and then you have these 2-part assemblies. I guess they go together something like this, maybe. Yeah. Anyways, probably a spring in between here. Something. Yeah. Let's check the manual. But these are supposed to take out the backlash from your lead screws, because lead screws always have a bit of backlash in them. Okay, optional upgrade, but oops, there we go. Anti-backlash nuts, definitely worth it. Now the question is, okay, we would need to grab a different manual for that. Okay. So let's just get to assembling. Let's just assemble the regular one and see how that works out, and then switch over to the upgraded one if we need it. Where did I put that box? Yeah. Packaging. So much packaging. Box. Let's just use it. Why are there no empty filament boxes? Come on. Box lid also does the job. Parked right there. Okay. Let's just assemble the regular ones for now. My question is going to be, did they include the regular M3 screws for these? That instructions were on the back. Oh. Why do we need those instructions? Now I'm gonna have to look for them. Where did they put these? Come on. Whatever. Okay, let's build it with the basic nuts. Executive decision. M38. That looks like an M36. And apparently they only include the screws you really need, so we will need this. Where did I put that box? Instant parts. Probably threw it somewhere. Okay. That's also not the... There's also not the M3 screws we need. Let's just try these. These are M3 by 6. So they are... These, at least they look like it. They might also just be the correct size, so you might get lucky. Screw these together. They're definitely not the cap head screws that you are expecting. So these have a 2mm hex head, which means I'll need to grab a 2mm hex key from somewhere. I usually have some around. That's a 1.5. It's also interesting that there are no tools included, especially like the smaller hex keys. Usually when you get a set, those are not included, like the 2mm ones, they don't come with that. So let's see, that might also be a 2.5. Yep. Let me just see if I can find a 2mm hex key. I did bring the regular set of hex keys that goes down to 2.5, but yeah, no 2mm key included. I will. Which one do I? Okay, one of these should be the correct size. And yes, this one is. Yeah, I did. It was not a box. I was looking for a box, but I was just looking for the bag. So the bag we found. Question, chat, let me know. Anti-backlash or not? Should we just put on the stock backlash-ridden nuts, or should we use the upgraded anti-backlash nuts in this build? Tom should 3D print some custom keycaps on that one Hao thing. Maybe. Yeah, these are actually just standard cherry keycaps, MX sort of things. So that could work. Anti. They gave you 6 to both. What? You can only put one set of nuts on. Anti. Okay, so what do you do with these? Do you just throw them out? I guess I can keep them for a project. I just don't have any spare high pitch lead screw though. Okay, so that is decided. No need to install something you might regret. Yeah. Assemble components. Okay. Just gonna zoom in here and look at the screen. So that's our assembly instructions right there. So we use the small, yeah, whatever. Okay, we'll figure it out. We will figure it out somehow. So we're not going to be using these M3 screws. I might need to go and grab another M3 nut because I did drop one. Thanks for the mods, by the way. Much appreciated. Okay, where do we start? Assemble components. So this one set. There's an arrow right there. So these go. Where is that? Okay. Okay. This part has an arrow right here that faces that way. So we get the larger half of the nut that apparently gets inserted. Yeah, that definitely gets inserted in here. And I'm thinking we need to line it up with the through holes right there. So, like this. Maybe. Well, there's some 3D printed bits sticking out. Because of the stream today, there will be no stream tomorrow? I don't think so. Why not have 2 streams? Okay, then what? Then we screw this all together. Cool. Maybe 2 live stream special? Yeah. There's not going to be a live stream next week, I think. Maybe. Saturday? Saturday maybe, but not on Sunday. So no washers on this side, which is okay. Belt system is bed for milling. Yes, it is. Too flimsy. Unless you have your software very well optimized. Yeah, I mean, I might have to push the Halloween episodes back a bit. Those were scheduled to come out today. I've not finished those yet. I still have to shoot some more footage and edit it. But, well, whatever. I shouldn't have said it. I shouldn't have said Saturday in the video because, like, the quote was, "The Halloween episodes will come out every Saturday." I should have just said weekend. Give me a bit more leeway there. Do a live stream every day? Why not? Well, if I don't want to get anything else done, then yeah, I'm gonna do live streams every day. But just look at like the ratings of live streams and live stream as content. Not everyone likes them, so yeah. Thanks for the tip, Camille. Much appreciated. 610 watching? Interesting. On a Saturday. I don't have a 2.5mm bit for the cordless drill. I should have bought one. Mach 3 and a decent mainboard. Are people still using Mach 3 plus serial port? I thought that was like 2002 when I last saw those. Shouldn't these be lock nuts? Yeah, maybe. Which is like a yeah, definitely. But it's looking like it's holding up. The thing is, you know, with lock nuts, Yeah, lock nuts like nylock nuts. And that would definitely make sense here because you are pressing against a polymer, aka plastic 3D printed part on the other side. So the screw heads up here, the screw heads up here are actually butting up against this printed part. So they are going to sink into the part over time as you have tension on these. So if you have regular nuts, those are going to come loose over time. So yeah, hold on, let me change a quick setting here. There we go. ISO limit. Why can I not set an ISO limit? Whatever. Okay. So auto ISO, just to get that brightness up. Okay, first one done. Then of course you get the springs that go over these, and I guess you thread in the your lead screw and then add the other one, which means this part is always going to be pressed into or in this direction. I'm hoping that was assembled correctly. It looks like it. Yeah. Am I going to get any of Joel's specialty protopasta filament? Not for now. Yeah, he actually asked me if I wanted some. The thing is, if you look behind me, there's already more than enough filament. It's already piling up over here. I don't need more filament. So for now, no. I should ask him if he wants some of mine. That's kind of coming together. We're doing a third run with dust filament. Yeah, there we go. So we had the first one, which you might have seen behind me in a few prints. I used it on the CR10 build. Then we did a second one, which wasn't all that spectacular. And yeah, now we're doing a third one that is hopefully worthy of the name Infinity Blue. Any idea when the next 3D Senpai live stream is? Not yet. But at least a month away, at least a month out. And I'm hoping that's going to be the DV3. I'm hoping that's actually going to be the one that gets shipped out to patrons. I do have t-shirt designs. I do have the filament, planned out and worked out, and we're going to have something that we can actually ship without paying $50 per roll. So that's figured out. I just need filament to be done, basically, and then I can start shipping some stuff out. But if you know me, I mean, I want it to be something that I would print with as well. I don't just want it to be something that is like, yeah, here's marketing item A. I want it to be something that I'm proud of, that I would personally use. Same with the t-shirt designs. I do want to I do want something that is actually wearable. So yeah, filament is coming along. We're getting there. This stream is going to be noisy, isn't it? Yeah, I think so. If it works. So I do have some, it's off camera, but I do have some acrylic here. I do have some MDF and some rolled aluminum, which I know is horrible to machine. I've tried to machine on a different machine, the Mendel Max conversion, and it's possible, but it's just not fun. So I think we're going to start with the MDF, which should be the easiest stuff to machine. Okay, can you see it on camera? No. We're going to start with the MDF. And then maybe we're going to move to acrylic with a lot of cooling. Oh, God. There we go. And if that all goes well, then maybe we can move on to the aluminum. Did you 3D print the parts yourself? No, that was all part of the kit. The kit came with everything you're going to see today, except for the Makita router. That is a part that I bought myself on Amazon. If you want to get one like those, of course, linked in the description, Amazon affiliate link, yada, yada, yada. So yeah, also links to, no, wrong way. Links to CNC, etc. also in there. No coupon codes, no special deals. Not today, at least. Yeah, the thing with the Bosch hammer is the cordless one has this belt clip on the back and no rubber surface. So this one isn't all that great to use as a mallet. So I'm not. How much will the filament cost patrons? Nothing. I'm paying for that. It's not going to be a full 1 kilogram spool. It's going to be 500 gram spools because shipping is going to be much simpler that way. If we stay under 1 kilogram, it's going to be 7 euros for shipping and not like 25. So it's not going to be full spools, but the 500 gram spools that I'm shipping out, those will be free for my long-term, well, not long-term, for my dearest patrons. Let's put it like that. The people that have stuck around and supported me for a while, those will get free filament shipped out or free t-shirts. Again, low cost. I'm paying for that as a way to say thank you. Might become a regular thing even. Who knows? Shipping to Australia will send you bankrupt? No, it won't. It's the same $7 worldwide. I think you can't ship to like North Korea or anything, but anywhere worldwide. No tracking though. And yep. And yeah, Das Filament is sponsoring the filament cost, so that's much appreciated. I would have ponied for that. I would have ponied up for that too, but they were like, hey, yeah, we're going to sponsor the rolls for your patrons. And basically, as a trade deal, they will keep the color in stock. If you want to buy more, it's just going to be a special edition color they have in their store. Okay, no, it's not going to be a monthly box. Can't really do that. Yeah, so if you want to just buy some, Das Filament is going to have it in their regular store. I don't know how well they're going to be doing international shipping. But yeah, so we have 2 screws left. We have 2 M3 screws left over, plus a nut. So the one I dropped isn't a big issue apparently. Install onto gantry. So I guess at this point we get to follow the regular build manual. Why is it so blurry? Install onto gantries and then compress springs and thread onto lead screws. So that is just the regular build manual. So let's jump back into that one. This is my first time building this kit. Yes, it is. It's actually, so I've done some CNC, some DIY CNC stuff before. But this is my first time building this exact kit. What model Knipex is this? 2612-200. So yeah. Which one do we need? Which plate do we need? So we need the one that has... Is that the... so that's the Delrin part. Palm. Okay, board GXZ. Put 290-degree offset on OSP board G. Why wet? Cool. So those are M5 by 25. So I'm guessing that's these. There aren't any other sizes there, so that must be the ones. That webcam looks horrible. I should really put the GoPro up there. We drop, which way does this go? I guess this way. Okay, so that's the orientation the manual shows. Yeah, 2 holes right there. Drop one of them on with this orientation, screws through here. The white balance is way off. Yeah, it's just a cheap HP webcam. Supposedly full HD, but I don't believe that. It's some upscaled crap you're getting out of that one. So might have to look into. I'm missing bits. Might have to look into what else I can use. I don't want to just get another Panasonic G7 and drop it up there. Though to be honest, I was looking at just getting a GH5, so I would have one spare G7 for this sort of stuff. Let's see. Was I at the Maker Faire Friedrichshafen today? No, I was not. There apparently is also Maker Faire at the Bodensee today. Hold on. So this one has the arrow facing this way. Then this one needs to have the arrow facing this way. Okay. Like that, and then you get a nut through the hole. Fingers cut on the band so someone slashed their wrist with a chisel. Cool, that sounds like fun. Not really. Hope they're okay. What am I going to use for dust collection? Wrong plate for instruction. Well, point A, these screws are too short for this. Oh. Wrong plate for instructions. These don't have, so yeah, these plates don't have any numbers. That's true. This looks, again, I was wondering, this looks weird. Okay. So use the other plate, but then again, these plates just have, you know, they're just a plate. I looked at this, like, there's some holes there, there's some holes here, and that looked like the right thing, but it's not. So which one do we use? Do we use the metal plate? That would make sense, because then we get... yeah, then the screws would be long enough. Okay, instructions. My old enemy is back. So... okay. So we need to line up holes. So if you can see this, there are some different sized holes. It might be hard to pick up, and you do have to pay attention again. So that's a large one, that's a large one, that's also a large one, and there's a large one. And they're small, small, small. So this is neither rotationally nor, what's it called, mirrored symmetrical. So there's only one orientation that this is gonna fit. So 2 holes go up here. And then we put this guy on with the arrow facing this way. Okay. Okay. Smells like paint. Interesting. Then this guy goes with the arrow facing that way. Cool. No washers. Just the nuts. So I think, yeah, bringing this down like that is going to be the smartest idea, because you cannot tighten the nuts on the other side. There you go. Which way is this? Is this nut recess supposed to clamp down? I guess kind of like that. Maybe not rotate that much. Let's try that again. I guess it's going to drag itself into position. You need the other bracket? What? You might be a bit late. What are my thoughts on using AC current, cutting the voltage to zero, crossing and PID to feed energy on a heated bed using low volt? Ooh. Ooh. Sputnik, that sounds like a bad idea. Because insulation and stuff, I really don't want any 240 volt. I don't know what voltage you're on, but I wouldn't want any 240 volt power on a PCB that is exposed and open and non-insulated. Just don't do it. Don't do it. Okay, there's our first plate. Yay. Now we assemble the Delrin one. Okay. So screws through here and nuts on top. This is symmetrical, so the arrow does not matter. That's cool. So this one done. This is, I like how heavy this is. Now we get to assemble this guy. So 2 screws in here. Somewhat tight. 3D printed parts. You can't imagine that 3D printed parts work well in a CNC environment. Well, it always depends on part geometry and how beefy you make them. These don't look particularly beefy to me. I mean, I could see a bit more material being used here, but just because it's plastic, just because it's 3D printed, doesn't mean it has to be weak. You can design a CNC machined aluminum or even steel part to be weaker than a plastic part that comes off of a 3D printer. It's not about the technology you use, it's how you use it as usual. Let's see if we can get these two. Yeah, I guess not. The regular torque that M5 needs. Let's see, usually we just need a tiny bit of... Here we go, more leverage. Have you guys seen the E10, CR10, like what do you think? Yeah, actually Gearbest sent me an email about that one yesterday. Yeah, it seems like ANET just went like, hey, the CR10 is selling pretty well, we want one too. It seems like the CR10 is making a few better design choices just when you're looking at the profiles, etc. But yeah, it'll have to, you know, the machine itself will have to prove itself. You can't really judge it from a Gearbest or AliExpress listing and a few pictures. That rarely does anything justice. So yeah. Would you guys like me to try one out? That's the question, I guess. Why no MOSFET? What random questions? Yeah, would you guys like me to try out the E10, the CR10 style Gearbest, the Creality style, the Creality CR10 style ANET machine? Is this the one we're supposed to be using? I think so. Yeah. Okay. So, wheels. Go for it. I mean, I do have a shit ton of printer reviews, etc. coming up. Just putting that out there. My queue is long. And the more you guys want me to do reviews, the less guys, etc. I'm going to be able to do. I don't have infinite resources. So the question is always going to be, do you want me to do this more than you want me to do other things? Okay, so one nice touch I'm seeing here is the wheels they're using do have, you can actually see it in there, do have the shim on the inside, which means You're not going to be squashing the bearings as you tighten this guy down, so you can actually tighten it nicely and get good rigidity and not have the bearings bind up. So yeah, that's nice. That's nice. And washers, that's the M5 washers right there. That is yeah, metric. I only do metric shit tons. Okay, so all of these have the washers inside. This is almost a bit overexposed. So we're putting 4 wheels on this guy. The E10 is smaller than the CO10. Really? How much? I didn't look at the listing much. I just looked at it. Was like, oh yeah, look, it's a CO10 knockoff, which by itself is also apparently not Creality's original design, but whatever. So that might be the wrong hole. I know. So with the, let's see, with the this way, the 2 large holes up here, we drop in we lose a washer. We drop in a wheel. We drop in the eccentric nut insert into this one. And on the bottom one as well. So this one has the eccentric nut on the back, so you can adjust the wheel right there. And in this one, same thing, same story. $200 by 270 by 300 for the ANET 810. That sounds pathetic compared to the CO10. By the way, is Nightbot online? Let me just check him. So, do we use a washer on the back? We do not. Okay. So straight nuts right there. Is it really eccentric? Well, these are. As you turn these, they allow you. So this hole is a bit larger than what the M5 needs. So it allows you to move the wheel around in this hole within constraints. But that's how you adjust these rails. It's the same with any open build system. You have 2 on one side that are solid, so these 2 don't adjust, they are just locked in place. And these 2 on the opposite side, you can rotate these nuts and you basically move the wheel further away or closer to the lineage or to the track. Nightbot is on, okay. Perfect. Yeah, as usual, I do prefer Nightbot a bit more aggressive than he needs to be. I don't know, just gives me peace of mind. So I should really be using a wrench for this. And I do have my wrenches right here. Not all of them, but the ones I need. Which size is that? No, 8, 9, 8, 8. So the ones with the regular nuts, the ones right here, these we can tighten up all the way already. There you go. It's 10 Newton meters roughly, should be fine. These we can tighten up. These are going to stay down. The other ones, the adjustable ones, these need to stay a bit loose, and we adjust these once we drop them onto the rail. Okay, these are still loose, so you can still rotate these more or less and adjust them. It's And still quite a hefty plate. Okay. Step done. Match the eccentric nuts to the larger holes. Yeah, okay. If you can't drop the eccentric nuts into the smaller holes. Okay. That's done. Now more wheels on the rest of the holes. Okay, same thing, same story. Is that what those numbers on a drill mean? What? The numbers on a drill, if it says 3, it is a 3mm drill. If it says 5, it's a 5mm drill. That's the only numbers that are supposed to be on a drill. If there are any other numbers on a drill, maybe throw them out and get ones that have some meaningful labeling. Oh, drill. Hold on. You're not saying drill bits. You're saying this thing. as I'm ranting about numbered drill bits. So these are that they are roughly Newton meters. Roughly, I've tried it out on the Bosch ones. The Bosch ones are pretty close. The Bosch clutches. So you're saying the numbers on a clutch. Yeah, these tiny 10.8 or now they're called 12 volt. Cordless drills, they match up fairly well to what a torque wrench is going to set it to with 1 to 20, etc. Newton meters. At least on the Bosch drills, on this series. Roughly. It's good enough for that sort of thing. Alright, washer, don't forget these. Nope. Well, yeah. This is going to need a larger one. Arduino shield, yes. F4CJZ is asking, could we have some news of the invisible resin frog? Thanks for it. Haven't had the time to play around with it yet, so I've been running around like a headless chicken for the last few weeks, trying to get a few things done, and the duplicated D7 was not one of the things that was on my list, so haven't really had the time to play around with it yet. The resin is boxed up, the resin has not set up yet, which is good. Even like out in the open, no black covers over it. But yeah, just haven't had the time for it yet. Again, you guys want me to test the ANET E10, then something else is gonna get is gonna go on the slow track. Yeah, Steve M, if your driver has no clutch or no torque limiter, then you're not going to be able to use that for accurately tightening down screws. But ooh, look at that, it rolls. But I always tighten my screws like that. Wood screws, not so much, because I want them to be flush with the surface most of the time. But if it's machine screws, you know your torque numbers for specific screw sizes, like an M3. I'm not going to go beyond like a 1 or a 2. An M4, I can tighten up to 4 or 5, and 5 can go up to 10, etc., etc. And then 6, basically as much as it gets. And then they're going to be torqued to their nominal torque and not going to come loose. So that's a nice thing to know and a nice comfort feature. This is not an impact. Not this one. That's not an impact drill, by the way. That's just a regular driver. Yes. This one is. Steve M's is also not. Okay, this one is binding because I didn't put the washer in. Cool. I thought I forgot one. Love to see a test of the Diamond Hot. And which one? The genuine one, or the one that you can buy as like a E3D quad a triple hot end on AliExpress. Have I ever found the original frog in my backyard? Well, that one's gone for a while. Okay. Look at that. That's smooth. This one's a bit rough. So I guess these aren't tightened down yet. So I guess the shims on the inside or the wheels aren't machined that precisely, which might hint me towards these not being genuine Open Builds wheels. Again, I think the Open Builds wheels have custom bearings, I believe, with not just the 625 engraved on the sides, but actually Open Builds engraved on the sides. I think I might be wrong there. That's what my brain's telling me right now. Will I try 3D printing on this? I don't think I should. Okay, let's see. That's done. And we're moving on to, again, eccentric on side here. We're moving on to the Delrin plate. Not much to do wrong there. Nuts go in the counterboard parts. Will I ever be doing a live build of a Core XY? Well, it depends on what you think a Core XY is. Maybe I will, maybe I won't. But from what I've realized, people don't know what a Core XY is, and they keep asking for it. Can this mill aluminum? I believe so. At least on somewhat slower settings. I mean, you're not gonna do hotkeys. Dope. There you go. You're not going to be doing any sort of HPC, high performance cutting on this thing. I mean, that's out of the question. But you are probably going to be able to do some light duty aluminum. Maybe not use like an 8mm roughing bit and just go through it like crazy. But with reasonable feed rates and with reasonable pocketing strategies, you should be able to mill aluminum just fine. From what I'm feeling here, from how solid this machine feels to me, aluminum should be fine. How tough is machining 3mm carbon fiber sheet? It's not tough. It's just the dust, just getting everywhere, and it's carcinogenic, and it's like not good, not good. So it's probably not something you want to do if you can avoid it. That it would even do a 0.2 inch. What is a 0.2 inch? Do you have that in metric? Cut without cheddar? I mean, there's quite a bit of weight on the tool head, so I'm not too worried about shatter. Yeah, carbon should be cut on the water jet. That is probably the best option, yeah. Like carbon fiber, again, I wouldn't want to mill that. It's more of a grinding through it, really, because you're not really cutting it. You can cut the resin, yeah, but you can't really cut the fiber. So you're more like slowly grinding through it, which again just creates a whole lot of dust. They don't want to have floating around. Chip and cutter cooling, correct? Yes. So yeah, I'm gonna get some. I'm not gonna be able to get in here with the. Well, maybe I will. Okay. We'll get my socket wrench in a second. That's good enough. Yeah. Cooling aluminum on this thing is going to be fun. Big air quotes there. Because aluminum just, yeah, Cutting it with coolant is your best option, and this entire thing is MDF. This entire thing is wood, so you don't really want any excess amounts or excessive amounts of coolant slushing around in this thing. So yeah, that's gonna be interesting how well we get it to cut aluminum. All right, so this one is assembled. Again, we're gonna have to tighten those down once we get it on the rails. These are in place and these are still somewhat loose. That is as intended. Next up, motors. So SM and PAM and M38. It's interesting that they show, no, can't zoom. Okay, that's not a control key. They show the in-hex screws right there, but they actually include the little mushroom head screws, which I guess do the same job, but these use a 2. There we go. They show the in-hex screws there. These use a 2.5 millimeter hex key, and the ones they are including use a 2 millimeter one. So yeah, just something to keep in mind. But we attach SM to PAM with M38. Stepper connector, okay, out the bottom towards where the labeling is. Okay. This one's done. So 3, we have, now the interesting thing is we have 5 seemingly identical stepper motor mounts. Why do we get 5? That still doesn't make any sense to me. But yeah, stepper motors. And then there's the labeling. There's the imprinted font right there. And we have the connector facing this way. Okay, outside. This almost looks like you could attach a Bowden line to it and use it as an extruder. But yeah. 2 for idlers. I don't know why you'd want an idler for a lead screw. Doesn't seem to make any sense to me. Perfect. The spares. I don't know. So I'm hoping they're not just betting on the fact that some of these will break and you're then gonna have 2 spares. Printed parts could be a bit better. Yeah, I mean you can tell they're printed fast, they're printed hot, they're printed with a maybe even a bit larger nozzle, but definitely huge layer heights. Print quality, I mean, it's not an issue as long as stuff fits together, as long as these holes are maybe reamed out. But yeah, print quality is pretty poor in these parts. It's not that it matters, as long as they are strong. But yeah, could be nicer. It's all about speeds and feeds at that point. Isn't it always about the speeds and the feeds when it comes to cutting anything? Just looking at all those missing sections right there. They're not missing. They're not gaps. Just like little startup missing blobs. Steppers will demagnetize each other if put in proximity of each other. Nope, that is 100% not true. Because the magnet is on the inside. The magnet is on the inside of these. The outside is just, you know, regular sheet metal. stacks. There's a term for that. Okay, more screwing. I thought I had cut off one of these 2mm hex keys at some point so I could chuck it in a drill. See how hard it is to break a spare? Well, first I want to know that they really are just spares. I don't want to break a part that I'm going to need. Are the motor connectors the good way around? Yes, they are. So supposedly you're supposed to have the text on this side and the connector on the same side, and that's exactly what the manual shows right there. Okay, tiny screws and tiny holes that are a bit tight, but at least they're the correct holes for these screws. Ow. All right. So again, I think this entire setup is going to be fairly stiff, fairly rigid. Again, we are using these beefy aluminum profiles as linear guides that are screwed to something on their ends, which is the MDF frame. It's a box frame, so that in itself is going to be fairly strong already. Okay, T-handle Allen wrench. Yeah, I don't have them in 2mm. If these were, I guess I could just grab a set of regular hex key, regular 2.5mm hex head screws, but these little mushroom head types, they have that 2mm size that I don't have in any other, any other tool for. Than these crappy, cheapo L wrenches. So that's what I have to use, unfortunately. Not sure why they didn't just go with standard hex or even Torx screws. The other end of the extrusion. Okay, so that makes sense. So, okay, I was wondering about that, how the aluminum extrusion would be mounted. Okay, but that makes sense. So, guessing these just go in here. Boom, done. So you screw, these are going to be the screws that attach to the frame, I think. And then you have the threads poking through here. You just plop a screw through these, and that should be secured quite well. Okay. That makes sense. Now I know why they have their shape. You can use a Torx and a hex. I could make a dirty joke here, but yeah, it's not. It doesn't fit well. At least these are all in roughly the correct position, and we're not like cross-threading any yet. So that's all good, even though I realize it's not the most exciting thing to watch. Most CNC kits take multiple weeks to assemble, yeah, or multiple weekends. It's sort of the same thing as with a 3D printer. If you get like a super cheapo kit and you've never done it before and you only have crap instructions, then it might take you a few weekends to get it assembled and tuned in and the entire thing set up and, you know, learn how to use it, etc., etc., etc. And I think it's just the same thing for if you build a portal style router. Ow! This one doesn't look like it's all the way tight, but I guess it is. The motor's not going anywhere. So we don't seem to be having any other thrust bearings other than what the motors themselves have. And usually these motors have a little spring washer in the back. So there are two bearings in here. There's one in the back. You can actually see it right in there. That's the motor shaft in the center. Then there's the bearing around it. And there's another one right up in here. And typically there's a spring washer on the bottom here. So as I push this down, typically on a stepper motor, you'd see the entire stepper shaft getting pushed into the motor body. So if I grab another stepper, that's the problem when you put stuff away, you put it all nicely in boxes, etc. But then you have to know which boxes to look in. Is that one that we can show? Yeah, I think this one is springy, I believe. So if we press down on this one, yeah, you can see that going in, right? So that's what happens with a typical stepper motor, because they have that spring washer in the back, and you can see that the bearing is a bit further recessed. These don't seem to do that. So these might be custom made. These might be built without that spring washer. So yeah, that's a good point, because if you were using just a stepper motor with that spring washer in there, you'd have a huge linear flex on that on the lead screw. So any forces would just, push that shaft in instead of, getting transferred rigidly. So that's nice. That is nice. Right. Assembly. Let's see what else we get. So linear rails. That looks good. So I guess each motor gets a rail, and we're using the short M8 screws. So 1, 2, 3. 1, 2, 3. Cool. What are you guys talking about? Hammers? Vice grips? What? Okay, short M8 screws. So this is all stainless hardware. And yep. Wow. There you go. And A270, that is A2 stainless steel. That's the type, I think that's like a 4 something, 40, I don't know which one it is exactly. A2 and 70 is the strength of the screw, the yield strength. So that is basically as good as an 8.8 screw that you have as a regular steel version, as like an anodized, not anodized, zinc plated, what are they called? Regular typo screw. So that's pretty good hardware, probably overkill. But then again, stainless hardware really isn't that expensive these days, and it certainly makes sense to use them in contact with aluminum, and it also just looks nice. Galvanized, yes, correct. Thank you. So what I'm sort of missing here is any sort of alignment tools or any ways of aligning things at all. This is just relying on the 3D printed parts to be dimensionally accurate, to be I see the gaps you guys are talking about here. To be, rectangular, square, to be dimensionally okay. There's nothing that you can kind of adjust or like tweak to get stuff in the correct alignment, which is bold, but probably you don't need any adjustment at this level of CNCing that we're going to be doing. Some NSCs in the between stainless and aluminum. Well, it's, you know, it's an M8 screw. If it gets stuck, if it doesn't come out, then I mean, I can always put the impact driver to it and just bang it out. Let's see if this one is actually cut well, because this one does not like, it doesn't feel like it wants to go in. Oh, it looks good. Let's try that again. Okay, just a bit tight. Yeah. Okay. 2 down, 1 to go. Yutaka Takin something. Sorry. Still puzzled why they use stainless heat breaks with aluminum heat sinks on hot ends. Well, what else would they be using? Aluminum heat breaks? Then the heat break wouldn't be doing its job. Stainless heat sinks? Well, then the heat sink wouldn't be doing its job as well. So yeah, you need that combination of materials to get a hot end that performs best. Of course, you can go with something like an E3D V6 or a Light 6. It's not a V6, it's a Light 6 that uses an all stainless construction. But to get that to perform, they actually put a Teflon liner in the heat break, because the stainless steel heat sink does not perform as well as the aluminum one. They could use copper heat sinks. Yes, they could, but copper, first of all, copper is not your friend. Copper is your enemy. Wherever you see it. Copper is super hard to machine, especially compared to aluminum. Copper is expensive and copper is heavy. So in a situation where you want your hot end to be fairly affordable, in a situation where you want to pump out thousands of them per month, and in the situation where you want it to be as light as possible because it's zipping around, you don't want to be using copper. And the aluminum is like 80% as good thermally. So yeah, aluminum is fine. Okay, let's see. Well, aluminum isn't just fine, aluminum is actually the better choice. LS200. And we have SC for solid coupler and LS for lead screw. Okay. So that is LS200. I think that is the short one. I think 200 refers to this being 200 millimeters long. What about carbon heatsink? What are you even asking? Carbon heat? Come on. Maybe you want to make it out of diamond. That will work. Diamond heatsinks are great. Silver is also pretty nice when it comes to thermal stuff. But really, aluminum is fine. Do you know about the Pico hot end? Yeah. Ooh, we found the 2mm hex keys that we were looking for. Nice that we find them now. So yeah. All right, aluminum couplers, anodized blue. These look like an OC car part almost, with the bright blue anodizing. So this one goes on here. There's no springiness in here either. So it's an all rigid connection. That is nice. I like that. Can you buy silent stepper motors? You can use Trinamic drivers that make your stepper motors pretty much silent if you set them up correctly. Carbon is full of air. What are you guys talking about? Carbon is a chemical element. Carbon is not full of air. Carbon is carbon. And then this guy goes in here. From which direction do we thread this in? From the side with the nut. Okay. So that is the small steel plate. So thread this in like that. Carbon can take many forms, yes, but the same way oxygen is oxygen, carbon is carbon, you know? Like hydrogen is hydrogen, etc., etc. You might be talking about carbon fiber, yeah, you might be talking about graphene, you might be talking about graphite. How do these work? Do they have anything that keeps this thing from turning loose? Or do you just... Ah, okay, so you... I guess you compress these together, right? Slot in slot, like that. Okay, that makes sense. Let me get you a close-up of that. Let me get you an in-focus close-up of that. Come on! There we go. Okay. So spring over these. There are these tabs and slots on the corresponding piece, and you slot these together. You screw in your lead screw until it bites, and at that point it is tensioned. So this thing presses this direction, this presses the other, and basically it just keeps the backlash in the lead screw preloaded in one direction. It's not like entirely backlash free at this point. I mean, I can still hear it clicking, you can still see it moving, but at least it's like, you know, pushed up in this direction. It's always getting pulled in this direction. So yeah, it's not a perfect anti-backlash solution. I would like to see something that isn't spring-based, that is rigid, that you can adjust to compensate for backlash exactly. And I'm not sure how well that's gonna do in like load-bearing situations where it might be something pulling this way, but we'll have to see. We'll have to see. Okay. Router would easily override that spring. Yeah, I have a feeling it would, or it will. Okay. Ooh, look, there's my... What is that even? Okay, that is a... where's my hand? There's my hand. Potentiometer for DC motor control right there. Cool. Now it focuses. Obviously. This part's done. At least this one side, and on the other side we get another nut that we're going to do the same thing with the two-part anti-backlash assembly. So, what up next? Did we tighten this down real well? Oh, we did. And now we get to assemble it onto these buttons. These are Cherry MX Reds. They don't have any sort of feedback, so I might accidentally press one and not feel it. Okay, this one goes onto the short. Make sure to push coupler all the way onto motor shaft before tightening. Okay, this one goes onto the short rail. Let's try that. Let's get this thing to focus on something that's a bit more interesting. But you have been looking for that for ages. What? Oh, for that DC motor controller? No, I know it's there. I just haven't had a need for it for a while. That was actually intended for the other mill sort of style setup I have, the Mendel Max, the converted Mendel Max, which uses a 48 volt DC spindle. This is tight. This is very, very tight. This is actually too tight, it feels like. That is a 48 volt DC spindle, and how do we get this on? So much for these aluminum extrusions, all right. Precisely machined. Let's see if we can actually rotate this into a low tension position first. But it should rotate by itself. Yeah. Okay, that's better. So these eccentric nuts right here, these are loose, but they aren't loose enough to rotate on their own at this moment. So you do have to rotate them to the lowest tension position, and then they should slide on. Cool. Now that is, oh wow. So this is the lowest tension setting. These are all the way on the outside. Right there in this one as well. And this is tight. So okay, now it's kind of okay. But I don't know if this is actually going to be able to, if just the stepper motor is actually going to be able to turn the lead screw at all. Okay, so that is tight, but it's too tight for it to turn on its own, so we do have to line up the D on the shaft. With the grub screws. Right there. Does this machine have any sort of encoder for positional accuracy? No, it does not have any sort of that. It's just regular stepper drivers with regular 3D printer style stepper drivers. It's actually regular 3D printer stepper motors with regular 3D printer style stepper drivers. There is no feedback, so the machine does not know if it loses a step or not. And we're just going to have to see how well that actually works out over time, especially since these lead screws do have a fairly steep pitch. Again, feeds and speeds, we're going to have to see if we can, if we can get it slow enough to, I want to say print, but to mill reliably, to cut reliably. Okay, that's one. That is tight. And yeah, that is pretty hard to turn. Like, I mean, the stepper motors themselves, they're fairly easy, but this thing with the wheels on here, not sure how well that is going to to hold up over time, and how if it might just be too much drag, but we will see. Okay, that is one down, and then we just assemble the cross brace of that side. So same again, we thread through the opposite side. Rotate, we don't need to rotate these until you can no longer rotate the V-groove bearings with your fingers. Come on, it's already hard to push, so okay. Right, so this longer one gets screwed through here from the opposite side of where the nut sits. So just the thread rod right there. You could loosen them off. What? Loosen off the fixed rollers? The fixed ones? So the fixed rollers, they have closely fitting, these two right there. They have closely fitting through holes through the steel plate. There is nothing, there's no leeway. There's nowhere they could go. So yeah, I don't think that's going to do anything. Any play in the fixed wheel holes? No. That does not look like it's on straight. It is actually anything but straight. I don't know. There's no way of adjusting it other than pushing it into place. That looks better. But of course, this is not a machined end, so this is just the open lead screw end, and you are tightening into these threads, I guess. And this one is all the way in. Yes, it is. So it might just come a bit crooked. Looks good. Better. And then this one gets screwed from the opposite side. So from this, no, yes. Okay, from this side. So right here we do have to add the anti-backlash mechanism before we can screw it in. So that's this one. And then the spring, and this needs to come all the way back. We can push this guy in and not get the spring threads caught. Someone was asking about an Amazon.de link for something. I think it was for the router we're using here. Check the link. It should forward you to the correct Amazon store in your country. There we go. There we go. That's better. Are the adjustable rails? There are no adjustable rails. This is not a an adjustable nut. It's just a what's it saying? Adjustable rails? Adjustable nuts. Oh, okay. Yes, the adjustable nuts are on the same side of the rail. Wilson RJ, is it just me for $400 you wouldn't expect injection molded parts instead of ED printed ones? 3D printed ones? No, I would definitely not expect injection molded parts at $400, because each injection molded part is like how much? $15,000, $20,000 of setup. So we have one, and some of these parts you can't easily do with injection molding, so that's even more for those. So yeah, you're easily talking like $100K in injection molding setup. For a machine they're probably making maybe a few hundred per year. So yeah. I did not expect injection molded parts at all. At all. Let's double check this. This side, correct. So coupler on this side, motor on the left. We are good. We are good. Now I will adjust. Can I get to these? Yeah, I can still get to these when we put the rail on. I'm just going to adjust these in one set afterwards. Just forget what she said. No, it's... What? No, okay, that's a different thread. So, next up we add one of the stepper motor plus long rail parts to this carriage. Rotate the eccentric nuts until the gantry slides on rail easily. Okay, so these two right here, this and this one. Let's put these on the lowest tension setting again, so all the way to the outside. You can see where the screw thread is actually poking down away from where the rail is going to be. And these go in here. Okay, still no backlash, still quite tight, even though we are in the lowest tension setting. Your threads are backwards. What? What threads? What threads? Nope. Yo, no caps, please. Like, no all caps. No yelling. No yelling. Not doing yelling today. So this is all the way on the motor shaft. All the way on the motor shaft. Yeah, there we go. There's one. And there's two. You thought Nightbot is here. Well, I don't know if Nightbot is here. He isn't. Two-factor. Ah, crap. I don't have my phone with me. Nightbot. I mean, we can check. Are these ABS or PLA parts? These are definitely pretty sure these are ABS parts. They feel like they are ABS, and with the motors mounted to them, I wouldn't think they'd be using PLA. So, yeah. Okay, Nightbot is here. So, we should adjust these. Okay, so these up here are loose. That is interesting. And these on the other side, these are completely tight. And actually, look at this. You can actually see the, maybe you can't, but I can. You can actually feel and hear the backlash in these, or in the linear drive, even though we are using the supposedly anti-backlash nuts. But these over here, these do still have some place, so we get to adjust these. So this side goes in a bit, and that is just to make up for tolerances in manufacturing. Just, you know, if this hole gets drilled a bit off to the side, it's not going to matter. It's not going to throw off your entire linear system. That's that. That is also good. So let's tighten that down. Is Nightbot free software? Yes, Nightbot is free software. He is made by NightDev. They've been around for a while. I'm actually getting black fingers from something. They've been around for a while and basically, yeah, provide Nightbot as a free service, which I think is awesome. And no, he is not a person. Yeah, he might be able to hear that. Okay, open source? No, he's a service. Literally, it's a web page you log on to, and he joins your channel. Okay, so we got these two connected. Yes, short and the long one. So this is the Z-axis. And down here, I guess that's where the spindle mount is going to go. And this is going to be the x-axis, I believe. Yeah. So same thing. What are we doing? Okay, 1, 2, 3. Now the other part, and this. Okay, so the Delrin part right here. This is going to be the print bit or print bit tool. What do you call these? Your work surface, basically. It's interesting that they didn't use MDF for this, but went for Delrin instead. I would have been okay with just a thick, like a 1-inch MDF part. So, yeah. And as chat is discussing the pros and cons of doing injection molding in China, etc., let me just tell you one thing. I have worked with on various fronts. I've worked with Far East suppliers, and you basically you end up paying the same. Whether you go for local manufacturing and buy parts locally, or make parts locally, especially if it's like machining and or injection molding, etc. Whether you buy those parts locally and pay more up front and get them done well the first time, or whether you get them for a discount and then have to rework them and have to go back and forth and put in all the extra time to make the stuff work that wasn't made to your specifications, because Chinese culture is kind of like that. Yeah, that's good enough. We can sell that. It ends up costing you the same. So injection molding, whether you do it in your home country or whether you do it in a low-cost country, it's not going to be any cheaper. So, yeah. What if you own all the tooling? Good point. Printobot is actually doing that, or is trying to do that. They are doing injection molding themselves. Pro tip: they have employees they pay to do that for them. So in the end, it kind of, that you pay for the machines, for the tooling up front, and then you pay an employee to make it ends up being the same at some point. I skipped a step. What did I skip? The other end. Okay. Yeah, we would have figured that out. I keep okay, so let's attach that. Let's not skip steps. That's what I have you guys for, right? Thank you. There we go. Okay. This is starting to turn into quite a massive assembly. It feels good. I like that. I like massive. Especially when it's CNC, you do need weight. If you're building, or some people who are building CNC routers, mills, whatever, from just aluminum profiles, not like your machine profiles, but your regular square tubing, they'll just fill those tubes up with sand to give them more weight and a lower resonant frequency. So anything that adds weight, pretty much a good thing. You're not going to be going at the same speeds as you would with your 3D printers. So yeah, not going to slow you down. Is this machine open source? Yes, it is. You can open up the entire source file package on Onshape, clone it, make your own mods. It's a fairly detailed model too. Okay, did the missing step. Now on to these parts. Okay, we got that coupler goes same side as the nut. So the anti-backlash part is back here. This side gets the coupler. I don't think it matters that much. Bad lighting. Why is your top facing down camera so poor quality? Because it's a shit camera. That's why. Very, very simple. Very simple. And you are comparing, I mean, you are comparing like the deepest of whites when it comes to live streaming setups. That you're comparing black and white, apples to oranges. The most aptly, that sounds like I'm talking about the Apple IT brand. Okay, you are comparing like some of the best live streaming setups you can have. Like these are DSLM cameras. These are the regular cameras I'm using for my videos. There are 4K Lumix G7s, which I run on into a capture card. That's like a almost $1,000 per camera if you add everything up: lens, camera body, capture card, etc. Each of those perspectives is $1,000, $1,000. This thing, I think that was like 23 euros. So yeah, you do have to put that in perspective. This is 23 bucks. Yep, that's 1,000. So I mean, what you're getting for your money is still pretty okay, but just yeah. Machine learning and machine vision could eliminate employees. Yeah, maybe. Of course. Automation could eliminate employees, but jobs. Nobody wants to get rid of jobs, so we stay at, you know, where we were at. And this is getting political. I don't want to get into that, but yeah. White balance is off. I mean, can't really do much about that. Nope. Get over there. Okay, so this feels a bit looser than the other ones. A bit more, yeah, adjustment. Yep. Leeway there. Alright, turn this guy around and tighten down the other one. So there are two grub screws on each end. So there are two back here that grab onto the motor, which you can't see because this is a really tight corner. Maybe you can now. Two grub screws on this side. One grabs onto the D shaft, and the other just supports the back, and there are two that grab onto the lead screw as well. Yeah, so. Okay, so we do have, oh yeah, this has quite a lot more backlash. These two down here, these feel okay. I can rotate this wheel by hand, so we might need to tighten this up a bit more. But these back here are just all over the place. So first of all, this one isn't tight at all. So let's just fix that and give that a quick extra turn. That's the one that is non-adjusting. Wait. Ah, this one. Okay, the adjusting one. And that turned out of place. There we go. So that position is okay, a bit further. There. And now I cannot turn it by hand. I'll keep the wrench in here and tighten down the screw to lock it in that position. And now we have a wheel that is nice and tight. And the same on this side back here. I can't really get you a better perspective of that. But yeah, now this one is tight as well. Let's just compare that to what we had before. Yeah, there's no movement. The only movement that we're getting is because this surface isn't perfectly flat. There are some burrs left from the drilling or machining operation. Let's just say that from the machining operation of these parts. So yeah, and the screws are also sticking out. Okay. How straight are these profiles really? Usually these are just extruded aluminum profiles. Usually they're pretty darn straight, at least at this length. Straight enough for what you're going to do with this machine. That's for sure. So we've got this entire thing assembled. Yeah. Got it. Okay. Other end for mounting. There is spoiler board. What? Yeah, the thing is, angle iron, I think that is made differently from how aluminum angles like these are made. These are extruded, I believe, in a somewhat different fashion than that's the wrong bit. In a somewhat different fashion than how you'd extrude. I don't have the bit for that crap. In a different fashion than how you'd extrude angle iron, which I think makes the aluminum a bit, yeah, straighter, more precise. Iron is usually rolled, yeah, but I don't know. Yeah, I don't know about the angled parts. How long is the assembly going to take? I don't know. So if we look at how many parts we got done, I mean, I think we got the most finicky. This is heavy. We got the most finicky parts done. We've got there's the y-axis, the z-axis, x-axis done. Electronics should be fairly easy, mostly plug and play. We do have a few screws left. That's going to be for attaching stuff to the frame and for what is going to be used for? I don't know. But I think that the worst part is over. Like from now on out, you can check out the manual. The manual is online. CNC.com resources. So that's done. That's adjusted. Now we actually get something that's going to start looking like a CNC frame. I should have muted the mic when I drink stuff. Yeah, the thing is, I have no idea how long the entire software setup, etc., is going to take. I checked, there is like a half-hour long instructional video on, how to set up Kirimoto, etc., for this exact mill. But that is just, I think that is too long. I think, the information that they're getting across in that time covers like everything from CNC basics to what is feed rate to yada yada. I don't want to watch that. I know that already. So I'm not going to have you guys sit through that video because it just doesn't make sense. Instead, I will set this up with Estelcam, ESTLCam, which is a German-made software that is somewhat simpler probably than Kirimoto, and also not officially recommended. It's not an official software for this mill, but I know it. I've used it before. It's quick to set up. I've got black fingers, and it creates good G-code. So that's what we're going to use. So maybe a bit faster than... Let's actually the other one. Maybe a bit faster than sitting through that half-hour video. At least for me. I missed step 18. Did I? I'm not even at step 18 yet, guys. Come on. Thanks for the $10 tip, Bob. Love your videos. Always good to hear. Right. What is my profession besides YouTubing? It is YouTubing. It is actually full-time YouTubing at this point, but I am a mechatronics engineer by trade. Is it by trade? It's not a trade. It's a university degree. So yeah, mechatronics engineer. I've done things all the way from working in sheet metal. Yeah, which way does this go? In producing sheet metal tooling to engineering, automotive electronics, and project leading those, etc., etc. But at this point, it is YouTube and 3D printing that is my profession. That is tight. Right now I'm doing step 17. I'm doing step 19. I'm doing step 17. This is the very first part of the assembly. We might be having different manuals, but this feels right. This feels like I'm doing the correct step at this point. Can you feed material through it, as in mill things larger than the bed? DKTS00 is asking. No. If you look at the video thumbnail, or if you look at CNC Labs, I believe it is. If you look at their webpage, you're going to see that this thing is mostly enclosed, so there are side walls, left and right. This is the back wall here. This thing is basically enclosed for the most part. There's also a front acrylic panel, and all those things combined, I don't think will let you feed material through that is larger than the build plate. Maybe if you make a cutout back here, you might be able to put, or to have something poking out the back. But yeah, the pie. What the fuck are you even asking? Get real. Okay, next up, the slim front plate right there. Yeah, 3D printed SP is doing a pretty good job as a moderator. Not gonna question that. So I did earlier this year, I did take out the heating oil tanks of this house, which means we now basically have an extra, how much is it, like 15 square meter room. And of course that's right now that is filled with 3D printers doing their thing, printing Halloween test parts. They've basically been working 24/7 for the last I don't know, 2 weeks or so. And yeah, that is the plan. Is that's going to be just a separate room where, you know, milling etc. can happen, where 3D printers can work all day, and maybe that's going to be the room for a hang printer. I know I've been talking, yeah, I know I've been talking about that. Just as I say it, it comes up in chat. I know I've been talking about that for a while. I do want to do it. I just need to find the time again. You guys keep wanting me to do stuff like ANET E10 review, then yeah, other stuff is going to get pushed back. So we have the step 17. That's where we're attaching Y gantry to frame. So that's the back frame and the front frame plate. That's done. And so far, there is still no alignment that needs to be done here. Okay, side plates. There's only really one way this is going to fit together. Let's see. So this goes out of the way for a second, and then we grab these two. So that is the right side. That's the handle up top, and that's the slot for the acrylic front. And that's the left side. So this really only fits in one way, like that. Motor connector goes in the cutout, plops through, and we can assemble it. We can screw it off. Socks and am I wearing? I'm not even wearing white socks today. Come on, guys. If you're wondering why I'm not using the cordless drill for that, I somehow lost my 6mm hex bit, so I literally don't have the bit for this. That's the one bit I've been using so much for all sorts of things. And yeah, it just somehow disappeared. Spoiler board, yes, you would not want to mill into the Delrin surface. That is correct. And that is also something that I'm wondering what there's gonna come up here, how they're gonna solve that, if they have a solution for it, or if the Delrin plate is literally gonna be your bottom, the bottom part of your print bed. Okay, I shouldn't tighten these anymore. It's already sinking into the MDF. So this is where I kind of, okay, this is where I get a few question marks popping up in my head. So let me get you that perspective. Now, this is the z-axis right here, all right? Z, x, that's fine, x-axis is fine, but the thing I'm wondering about here is it's only these two nuts back here, 1, 2. These two nuts are holding the entire z-axis straight. So I could rotate this entire thing slightly, tighten it down, and we'd have a skewed or an offset or a crooked, whatever you want to call it, a z-axis that isn't perpendicular. Same thing with like dynamic forces. If you have something pushing down here, aka dynamic forces from a cutting bit doing its job, only these two screws and of course 2 more screws on the other side, those are going to be the only thing that holds this thing square. So it's going to be interesting to see how much, well, it's not plumb. I could tip it up and it wouldn't be plumb. So it only matters that it's square. It doesn't matter that it's plumb. So that's going to be interesting if whether or not that ever shifts. Like, you know, this gets some knocks if that plops it out of square. So yeah, we'll see. This is starting to look a bit sketchy. Okay, and that plops in here. A swarm of automated drones with spools of film, and it's scrolled away. Then what? You crazy. No washers here? No washers here. washes would be a good idea, especially against soft stuff like MDF. MDF really isn't a hard wood. Technically, it's not even a wood. It's a wood composite, wood engine, whatever it's called. It's a particle board and fiber board. Sorry. And yeah, washes would definitely help here, so that we could tighten this up a bit better. But then again, on the other side, we are tightening against plastic, so there's not a whole lot of of force we can apply, not a whole lot of torque we can apply before we start deforming the plastic. There's no provisions for a wasteboard. Okay. Aluminum special production. The aluminum is probably very standard aluminum. I mean, I don't think there's anything special about these. Okay, that looks good. So yeah, something's creaking, crocking. So I guess that's this side over here. Yeah, it is. So definitely not meant to cut with a huge bit. Something just broke. I don't see what did. Well, it's gonna hold together. We're gonna get the rest of the frame on here. It's gonna hold up. Might need to reprint this bracket in the corner though. Okay, yeah, 3D printed part. That obviously is the weak spot here. The MDF is a nice big sheet. The aluminum is not gonna break. That's the last thing that's gonna break in this part. It's gonna be the 3D printed parts, because those have layers. Those are plastic. Right, so we've got that assembled, and now we drop it onto the rest of the machine. Cool. Brackets in the corners. No butt joints, just the angle brackets. Twist on bolts on all corners loosely, then tighten on a flat surface. On a flat surface. What? So this surface down here. Okay. Okay. Should only mill beeswax. There are 2 nuts left over. Okay. There's our y-axis. And it's the same thing, by the way, here. You only have these 2 nuts and bolts in the front and 2 more in the back. So theoretically, in this direction, the weak point isn't this board so much, or the wheels, but it's these 2 nuts in the back, because there's going to be a huge lever on these. Okay, so this should theoretically just drop on like that, maybe 1. Does this go on the inside? Yeah, feels like it. Okay. So we now have a box. It feels a bit tight. It feels like it's not meant to be this tight, but let's see if these fit. The thickness of the aluminum. Should I measure the thickness of the aluminum? Oh, and these are threaded. Cool. So we can, in theory, just plop in. Yep. These M8 screws, and are these screws? Yeah, they're screws. They're not bolts. There we go, and it's gonna fall into position. Nice. FDM or SLA? Depends on what you're doing. Don't like German cars. Yeah, the thing, so for context, the discussion on durability or long-term durability and resistance of 3D printed parts, yeah, highly depends on the material, I'd say. So SLA versus FDM is going to have a huge difference in just what the material, what the finished print is going to be able to take as far as UV and the chemicals go. But also, if you're just printing FDM, there's a huge difference in just the fine details of what materials you use. Like, I've had an ABS part outside in direct sunlight for a while, and it's okay, that didn't speak correctly. I've had an ABS part in the direct sunlight for a while, and it looks good like new because I use black ABS, and that just absorbs any UV. Thank you for the €15 tip, Closes. My new hex key set. Yeah, I'm gonna get some hex bits from that. I do have the hex keys, but I need the bits for the cordless drill to make this faster. Do you guys like the text-to-speech? It's like the streamer standard that you have now. Is the stream broken? No, it's not. Aluminum thickness? That is... quarter inch? Quarter, no, eighth? Quarter inch. I'd say this quarter inch. Looks a bit thicker than 6 millimeters. I don't have my calipers here right now, so I'm just gonna use some non-precision parts. 6 millimeters. 6 millimeters is exactly. You think most people are actually cars? What? What type of router trimmer am I going to use? Yes, the Makita RT0700C. That's the, I think that's the European model. They also have the RT0701C. That's the US model, I believe. And the difference, from what I know, is the US Makita routers come with quarter inch, so 6.3 something millimeter collets. So you're going to be chucking up your quarter inch router bits into those, while the European versions come with 6 and 8 millimeter collets. So what I'm actually going to be doing is I do have these. These are literally all the bits I have for now. So let's just go on a quick detour here. So zip. These are all the milling bits I have. I have been using these blurry bits in my milling machine, which is just a glorified drill press. So that's a 2 millimeter one, I believe, 4 flute. Even that might not be the ideal one. That's a 4 millimeter 4 flute. That's a 3 flute 6 millimeter one, 4 flute 6 millimeter, and 5 millimeter. Yes, 4 flutes. So not the ideal bits for this type of router, but that's all I have. I'm thinking the 2 millimeter one, that's the one I'm gonna get the most use out of with this one. But in the long run, I do want to switch to 1/8 inch bits, just because they are the cheapest stuff you can get. 1/8 inch shank. These are 6 millimeter shank ones. shaft, shank, whatever the word is. And the 8-inch ones are just a lot cheaper. And you can get an adapter from 1/4 inch to 1/8 inch, or from 6mm to 1/8 inch. You just drop that into the 6mm or 1/4 inch collet, and you're good to go. Because you could get a different collet for these Makita routers, but the thing is, to get an 1/8 inch one, you have to get like the custom-made boutique type ones, which are like more than $40 for the collet, which is almost half as much as the router costs, and I'm not paying that for a collet. Yeah. Ooh, AliExpress affiliate links. Interesting. Nice Saturday show. Nice Saturday show. Thank you. Hoping that's enjoyable. Okay. Guys discussing the degrees. CNC bits. Yeah, I have all the cheapo all the cheapo AliExpress special 1/8 inch bits. They're like $1 per piece, which I find decent, tolerable. If you break one, it's okay. They don't last forever. You don't expect them to last forever with these cheap or weak CNC setups. They're okay. They cut okay. But obviously they're not the greatest thing ever. Don't buy collets from China. Well, you don't really have an option. That's the thing. If you buy these Makita routers, or even the Rigid or whatever others you can buy, there's no real option of just buying a quality 1/8 inch collet. I would, but again, the one option I have is $40, and that's just not worth it. Darby Cox, who are you asking that? Do you think you will ever move to the US? PX Caution is asking, the original planned router Rigid 5.5 is really cheap, $99 at Home Depot. Is there a cheap European alternative? Yeah, the Makita one. The Makita, I paid $105 for that, which I think is not super cheap, but it's reasonable for Makita. At least for here in Europe, that's not a bad price for a Makita tool of this caliber. Okay, not perfect, not perfectly true, but right. Yep, 105, and that's, well, on Amazon you pay like $140, but you can get them on all sorts of shops. So, all right, let's see. Twist bolts on all corners loosely and tighten on a flat surface. We did that. Okay, so next up, router mount, and then we add a router. So I guess it's a Makita unboxing time. And the front shield is optional, I assume. So for now, I'm just going to be using my shop vac for dust collection. Don't have any other ways of doing that, or just nothing at all, because the router plus the vacuum, that's just going to be really, really noisy. I will definitely put in hearing protection for that. We use the long and the short screws with these. I guess the Long ones? I'm gonna use the long ones. M815. Short ones. Okay. So, this way or the other way? This way, okay, with the screw holes facing down. Yeah, there is no provision for dust collection in here. This is just a very, very basic setup. There's not even a base. So this thing is completely open on the bottom. So I guess what you could do is you could just put it on like a hex honeycomb mesh something and just suck out all the dust through the bottom and just don't have it leave the machine at all. That would probably work pretty well actually. So that might be an option. But there is no like direct dust collection that attaches to the call or the router mount or something. Are there even end stops? No. No, there are no end stops. But then again, you don't really use end stops on a CNC machine. You use them on a 3D printer. But on a CNC setup like this, you usually align your you align your axes with, or your zero positions with the part, and basically touch your router bit on the part. So, come on. So that you always get the correct zero positions there. Why does this one not bite? Now it does. It looks like, it feels like it's biting, but it's not. The thing would tear itself apart if you try to mill metal. Well, I will, in fact, I will try to mill aluminum. Maybe not today, but I will definitely throw some aluminum at this guy and just see what's gonna happen. Just for reference, I have milled aluminum successfully with the Mendel Max, which is even less of a CNC capable design than this. It's a much flimsier design, and the aluminum parts don't look half bad. Of course, like I was doing some tricky stuff with trochoidal milling, etc. But in the end, the Mendel Max did mill aluminum, and it did not look bad. This is horrible to tighten. Someone was asking about some Bosch stuff. Usually use limit switches to not break your machine. Yeah. Yeah, I mean, $400 plus the router. Maybe you just have to use a bit of common sense. It's not a production machine. It's not a, it's not a professional machine. You are expected to put a bit of thought into it. Because yeah, of course, if you let it, it's going to break itself. Bosch Blue is their top line. Yes, sort of. Bosch has a few different lines. Green is like the everyday, household consumer stuff. A lot of the products are identical to the blue stuff, but the blue also have a few different lines. They have the cheaper tools and the more expensive ones. You can buy like the same skill saw for $200 as a blue Bosch, or you can buy the same size saw as a €600 saw. So big difference there. Just because it's blue doesn't mean it's good. Next up, me catching up with chat. 50 cents per end stop. Yes, right. I know. It's actually less. It's like 32 cents. Dollar cents. Right, we are adding a router. So Makita unboxing time it is. Crespin, yes, the Crest ones usually come up too, but the thing is, from what I'm hearing, is they are incredibly noisy. And I think they're also a bit larger than what we have here with this somewhat small one-handed router. I think the Crest ones are a good bit larger and heavier. This is literally a one-handed tool. So I don't know, how much does this thing weigh? Maybe 1.5 kilos? 3 pounds? So I don't think you can really compare this. So there's your handheld, what are these called? Plate to use it with, depth adjustment, etc. We're not going to use that. Wider than a router, okay. And oh, look at that. Is that dust collection? Do I see some dust collection provisioning right there? The problem is that attaches to, yeah, okay. That's not going to work. This attaches to the to your holder basically, and it clips in somewhere around there. So that's not going to work for our job, unfortunately. Thankfully, we do have 3D printers, so we can make some custom dust collection collets or throats if you want to. So there's your parallel guide. Not going to use that. That goes back into the box. The nice thing is, if I ever get dissatisfied with this setup, if I'm ever like, I don't know, I'm not using it that much, I still have a Makita router that is a nice one-handed trim router. So, yeah. What else? So there's another collet. I think that is the 8mm one. Let's get out here. So let's just grab a 6mm end mill. That's a used one. That's 6 and 8. That is not working. So 8mm collet. I don't have. I actually do have an 8mm end mill, but yeah, this is not it. So by default, I'm hoping this is a 6mm. Yes, it is. So get a small wrench and a large wrench. There we go. And this tightens down. And now we have a nicely chucked up 6mm end mill bit. Perfect. That works well. And I don't really know how true this thing runs, but then again, I don't really care about how true this thing runs. Only 3K RPM? What? That you're missing. You're missing a 0. This is a 30,000 RPM. So yeah, and it's adjustable. So there are. I don't know which one I managed to get here, but. There's your table. So there are like 6 different RPM settings on this on this. What language is that? On this router, so you can go from 10,000 RPM all the way up to 30,000 RPM. So even smaller milling bits should work pretty well. All right. That's that. That's chucked up. I don't know if we should be doing the first cut with a 6mm end mill, but I will take that out for now because these things are sharp, obviously, and I don't want to cut my hand open. There we go. Internal air cooling. Yes, I'm hoping. That is, yes, that seems to... No, that seems to be sucking up. Or, hold on, it's turning this way. Then it's blowing down. Okay, so this thing is going to be blowing over your workpiece. So it is blowing down. Which, I mean, makes sense. You wouldn't want to suck up all the dust into... Oh, we have a spindle stop right here. You wouldn't want to suck all the dust up into the motor. So, yeah, looking good. Follower, call it, small one. Not going to use it. Thanks for the $5 tip, Trevor. Much appreciated. Also, focus, yes. Focus. Cool. This. There. Let's see if you're going to need the this extra shim that's in here. Let's try with and then without. So, nope, don't need that, doesn't fit. Without. Fits, but just barely. Like right up here. I'm running out of camera angles because this is a box that kind of blocks everything. Right up here, it's pretty tight with the aluminum profile. Once we clamp this up, there's like 2 millimeters right there. But yeah, I think I'm just gonna make this flush with the bottom, which it is, to have as little of a lever as possible. And this should, how far does this come down? Far enough. Okay, so router as high up as possible. And right. 2 more screws, 2 more nuts. And the router is in. Cable to the left or to the right, shouldn't matter. How do you hold anything to the bed? I don't know, to be honest. 350k, yeah, PCB drilling. Cool. Would it be possible to cut a hole in the back and feed material through it? Yes. Definitely possible. Arduino is the next step. What? How large is the... it's interesting how terms get mixed up here. How large is the build area of this mill? First of all, it's not a build... or build volume, I think was the wording. First of all, it's not a build volume because you're not building anything, you're machining stuff. You're taking away material. And the volumes, most of the time for a CNC setup doesn't matter that much because you only have so far that a mill bit will go into the material before like your router or your mechanics get caught on something. So the most important thing on any sort of at least on a 3D mill that has 3 axes and not axes and not 4 or 5, is going to be your build surface. And I don't know, someone in chat is going to bring that up. Someone's going to copy paste the exact dimensions. Will I be adding liquid lubricant, as in a coolant? No, I will not, because this thing is built from wood. So, Kommt die Fräsung oder ein Kunststoffteil vorbei? Well, okay, so someone's asking, does the mill head pass this plastic part right here? So let's just visualize this. Because right here, there is only like a 2 millimeter gap, and this is overhanging. You can see it from the top. This part right here is overhanging. But the thing is, this entire thing actually moves as a unit. This moves up and down on this black plate. So the wheels are here. They ride on this aluminum profile. So this entire thing, including the motor, just moves up and down. So this is one unit. Mount down here, motor up here, and the black bracket moves up and down, and these wheels and this plate is the only thing that is fixed in height. How many kilowatts? A few, enough. I think it's 700 watts or something. Enough. It's plenty. This thing has plenty of power, definitely. More than enough. It's only to 1. I don't want to get like a shock when I first plug this in. Okay, this adapter, we're not using this. Back into the box with you. Okay, router is installed. Front plate. Not sure I want to install this yet, because it's just gonna... Well, I guess we can drop it in. Yeah, that would actually be really easy just to... just to like, because this is just a slot right here, just to drill a few holes, insert some LEDs, and just have this thing light up. That would be sweet. And you could do it like just from the side right here. That would be nice. I think we're going to be doing that. Will this pin be speed controlled by the Arduino? No. You set it to a fixed speed on this dial right here. You set it to a fixed speed, you start your cutting job, and it's going to stay at that speed for the entire cutting job, which is fine because you're only going to be cutting one material. Combining the Arduino and the CNC shield. Okay, this is going to be hard. Okay. And some electronics. Let's see. What kind of plastic did they print? ABS. Yeah, it's horrible print quality. But it doesn't matter as long as it's strong enough. I already cracked one part, I think. So, Arduino standard pinning. Pop. I don't think there's anything on this Arduino yet, so we will need to flash it ourselves. Let's see what the manual is telling us. Jumpers 2. Okay. Wow. Which one? So the two jumpers closest to the blue screw clamp. Okay. So 1, 2, so that's just micro stepping, and having 2 jumpers on, I think, is 8 times micro stepping. Might be 4 times. I'm not quite sure about that because I never change it on my 3D printers. 3D printers always run in 16 times micro stepping, all 3 jumpers in. Does it have a table on here? No. So, yeah, 2 jumpers, either 4 or 8 times micro stepping, I think. So EC. I don't know why they have to give these parts part numbers that are cryptic, because they call it EC. So EC is I don't know what it stands for, but it's motor cables, it's motor wires. And yeah, just call them. I mean, if it's a stepper motor cable, just call it that. Just give it the name stepper motor cable. People are gonna know what you're talking about, because these have no markings on them whatsoever. So yeah, board is touching the USB. Yeah, that's fine. That's fine. There is solder resist on this. It's not going to short anything out. So these have a 4-pin and a 6-pin end. Yes, they do. And these go on the connectors like so. Okay. Technically, a bit of the wrong connector. Practically it's gonna work. By the way, if you want to reproduce something like this, the parts for these, again, as some people in chat have been pointing out, you might already have if you've ever built a 3D printer, or if you've ever disassembled a 3D printer, then you're definitely going to have all the parts. And things like the Arduino and the CNC shield, that is CNC, not SIENCI shield. The CNC shield is like $1 or $2 for this thing. The Arduino is like $5 or so. So in total, if you add the stepper drivers, etc., the electronics plus motors are going to be less than $50. And then of course the wheels, the profiles, etc., etc. But you know, depending on how you build it, if you want to build it yourself, you could have yourself a nice, simple, easy, and cheap build as well. Or if you want to use any of these parts for other things, you can definitely do that. So, is there any position where I don't short anything out? Probably not. I'm not a huge fan of these little tiny heatsinks because usually they don't do much. They do more harm than they do good. You should be putting them on the bottom, but on the bottom there's no space. These are thermal wires. I don't think they do all that much on top there, so yeah. Don't forget to set the driver to 0.8. Let's see what the manual says. So these come preset at the center position of the potentiometer. Again, you can't really set the these stepper drivers to a fixed voltage. You can't really do that because they have different sense resistors. Some drivers have, some driver types have different reference voltage ranges that correspond to different currents. So you can't just set your drivers to 0.8 volts and have that as a universal configuration. So potentiometer goes towards the jumpers. So 1, 2, 3. Three. 3, maybe not. Okay, what's up? Why are you not going in? Oh, because this. Okay, the connector, this white mismatch connector right here is in the way. And that looks like it's in. Okay, can this do steel? No. Most likely not. Maybe with a tiny bit, maybe with the right cutting strategies, maybe going really slow, but nah, not really. It's not meant for steel. It might cut aluminum decently, but it's not going to cut steel decently. Right, done. The stepper driver should be tuned using the potentiometer on the front so that the flat edge of the dial faces to the left. This gives the stepper motor on the middle one the right amount of power to run effectively. Further tuning is required to turn flat either counterclockwise or clockwise will okay. While the board is powered up, well, I've been doing things wrong all these years. So we need a tiny screwdriver for these. Do I have one that fits? I know I had one. It's been a while since I've last had to adjust these stepper drivers. I did have a tiny one that fit almost perfectly. Let's hope audio doesn't cut out. I'm not going to grab the multimeter. I think this one fit almost perfectly. Printer still seems to be running. It's printing MatterHack as PLA at the moment. So I think this cheapo screwdriver fits almost perfectly. So they're telling us to turn it clockwise until the flat faces 90 degrees the other way. Missed pins, what? Check stepper pins, what? What? Pins not in? Pins not in? What? What are you guys saying? Stepper pins not in. What, this one? This one right here? Oh, the one next to it. Okay. Okay, that makes sense. Oh, that's quality components. Again, these CNC boards, they're pennies. So I guess it's no surprise that they don't align perfectly on the first try. So I think that's better, slightly. For an 8 for that build does not look suitable. I would agree, definitely. So yeah, right. Yeah, just in case you're wondering why you're getting banned in chat, no, yeah, subscribe to my channel. I'd really appreciate it. Check it out. Like, I don't come to your channel and spam, so you don't come to mine and spam. By the way, mods should have the report for spam button that is gonna, potentially get you blocked across YouTube. So don't do that crap. Right. Let's see. So adjust these. Okay. Yeah. Why did I plug these in? So we turn these 90 degrees. There we go. And this one as well. Cool. Cool, got that. PEH. So the PEH. Again, why those names? That actually has a... Nice. Actually has a cover that clicks into place. So this entire thing slides in. It's almost like a... Ooh, and then you snap the wires into place. XYZ from the back. Let's try that. That sounds like fun. So this thing plops in like that. So we've got the cutouts in the back for the USB and not for power. Wait, are we not going to feed this thing power? There we go. Does it run off of USB? Oh, wait. Okay, so we get this. That is interesting. Okay, so we get a separate power connector. I have a feeling like the barrel jack that is hidden right underneath here that the Arduino comes with, that would have been sufficient to run a few stepper drivers because the pins are broken out. The pins go up to this board. I'm not sure if they're connected on this board, but okay. Okay, and that's a 3D printed thread, by the way, that we're trying to screw into here. And it feels like it's catching. Yeah, but it is very tight. Power from blue connector, yes, that is, yeah, this open-ended connector is gonna get wired to the blue one. So, but for now, let's wire this out and route this out as intended. So this is X. By the way, because it plops into my head right now, I do have that text-to-speech enabled on Streamlabs tips now. I don't think I caught any responses there. Is that something I should keep on? I think it's kind of neat, but is it annoying, or is it something you would like to see kept on? You know, the voice output. Do you even hear that? I think you should. I think I tried. I made sure you'd hear that. And I feel like it validates me as a streamer, because that's all the streamers have that. So, let's double check. That is screwed in. We get that connected right here. Positive over here, negative over here. Barely audible? Okay. Barely audible. Give me a second. Give me a second. I can crank that up. It might be a bit too loud the next time now. Just be warned. I tried to do that for Super Chat as well, but Super Chat is like, kind of buggy at times, and doesn't work too well with Streamlabs. So. Right. So this guy gets just tightened into this blue connector right here. And we should just have like an overhead controllable, zoomable camera, kind of like a Twitch Plays Pokemon style thing, where people can control the cameras they want to see, and and maybe even control the camera. I could stream like all the cameras individually, but well, I guess I could. I'd have to run 3 instances of OBS Studio. Maybe I'll try that at some point. Okay, so that is wired in right there. That is literally just a barrel jack that goes to the blue connector right there. Let me actually replay the last super chat that was supposed to be read out. Let's see.
Nice
Replay. So I do have it playing on the TV right here. But did you guys hear that? I don't know. Sound is fine. Okay, box is assembled. Let's see what's next here. Second test. Sound test. Barely audible works very low, very low, very, very low. We can boost it, and we can crank it up to, I don't know, 5 decibels more. All right, but thanks for that. Very low. It would suck if that's only like being picked up from those speakers and then back, but not from the stream. Crap. I'll have to look into that. All right. So we wire this up. Where did the electronics go? So there's a cover that goes on these. that snaps on like that. That just it's clicked on, and there's like another connection down here that keeps everything neatly in place. I like that. And okay, so this is just like a clamp you slide onto the frame and it stays in place. Sputnika, thanks for the 5 RS. What is that? $R. Thanks for the tip. Anyways, cool. My hotkeys are not global anymore. And I don't see where my mouse is. Brazilian. Ooh.
One, two, three, test.
So if that was really low, again, I do have it on the speaker. You should hear it somewhat clearly directly pumped into stream. Let me just check what my audio output is doing here. It should be picked up.
One, two,
But-
three, test.
Oh yeah, it is really low. I'm seeing that. It is being picked up correctly, but it is low. Okay. With an echo, yeah, the echo is where so again I gave it a bit more.
One, two, three, test.
That should be a bit louder. I'm hoping. But yeah. Anyways, thanks for the tip. Cool. That goes here. There, that's better. Cool. More. I actually don't have any more volume that I can give it. I could lower my my vocal volume, but then the entire stream would be more silent. My mic is picking up. I know it is because I want to hear it too. Okay, what am I doing? I'm trying to wire this stuff up. So X, Y, Z. So in order, the top one is X. That is this one. We have Y. That is the one on the bottom here. No wire management. Just nothing. Absolutely no wire management, which is okay since all you have is the power cord for the router. For the, trim router. You have 3-stepper. Oh, there we go. 3-stepper cables, drivers, and that's it.
It's okay now.
Oh, thanks for letting me know. And thanks for the 5-year tip. I don't know how well the spam filter works on those, though. I'm just relying on StreamTip or Streamlabs to be reasonable. There's no extra layer like Nightbot on that, so don't be naughty, please. Mute desktop audio so we can only hear it through mic. That's too silent. You're not going to hear that. Right. Something's resonating in here. It is continuously on at steady speed. Yes. That looks like we are now fully assembled. Don't plug in your power brick yet. Simply connect the USB cable to computer and continue on to the next step. Open your favorite resources tab. Click on the software resources. 1.1V. The default settings for the CNC mill 1. Okay, so zip software resources. I don't know if I should just like tilt this over here while I'm doing stuff on the PC. Nah. You don't need to see me in the corner. Look at the mill. Look at that. Yay, Makita. We were going for, hold on. Software, you should notice a link to the firmware and firmware setup. So software headers, firmware. With Arduino IDE, Gerbil with default settings and following the instructions for the Gerbil. Okay, for 1/8 microstepping. Okay, Arduino IDE, we have that. So all we need is the Gerbil. Is there a proper way to pronounce that, by the way? Open up, come on. Please note that it works best with Nightly Universal G-code sender. Okay. Like I'm thinking we can just open up Prontoface and send it with that. That should work. Gerbil. Strictly for the V1. Okay, we don't have that, so they were using a different Arduino Uno. Why are you not opening up? Here we go. Okay. Universal G-code sender. Windows 10 time estimations. Cool. Let me quickly get that out of frame while I navigate my file structures. Okay. So defaults.exe, what? You need Arduino for this? Where's our Arduino project? Yeah, hold on. So we're getting inside the zip, we're getting the Gerbil folder. Well, was it even unzipped all the way? Getting the Gerbil folder, and we are also getting another zip folder, which seems to be just different. It doesn't have the default.exe in it. But how do we upload this? In Gerbil. I don't have a Discord server. Gerbil. Okay.
GRBL.
That shall be the official donation now. Thanks for the €5 tip. Okay, so how do we end by following the wiki page? Okay, let's follow the wiki page. Via the, okay. See the Gerbil library installations from the Okay, so we have the zip sketch. Okay, so this is our library and this is our code, I assume. Which means we do actually have to cut out the Arduino libraries, of which I do not have a I don't even know how you pronounce the rodent, so so there's no Gerbil folder in my Arduino libraries, which I guess is good. So Arduino Gerbil load Arduino as a library. Yeah, whatever. Java, best software ever made. And we've got Marlin open. Okay. So we want to do... Make sure you're using the most recent version of the... Yes, we are using a recent enough version. Sketch include library. So sketch include library, add zip library. And that is in downloads. Kerbal zip. File library added to your libraries. Check include library. So there should be something new somewhere around here. Updates are available from there. There's a gerbil. Okay. And I guess now we can open examples. Hold on, let's see what this officially says to us. Include, okay, got that. Open the gerbil, upload Arduino example. File, examples, gerbil upload. File, examples. You might notice I have a crap ton of libraries installed. Yes. Okay. Compile and upload gerbil to your Arduino. Is that it? But do we get a config in here somehow? Or is that already pre-configured? I guess that's, yeah. I guess that's all we need. So let's try that. Let's plug in some, I keep seeing my mouse cursor on the screen cap. So let's plug in some stuff. Only USB for now. So we do get a shown link USB 2.0 cable, 28 gauge plus 24 gauge cable. Go back to the instructions. What? Which instructions? I got the right instructions. It says not to use the gerbil zip. What? It says not to use the gerbil zip. It uses the gerbil.xxx file. What? Use gerbil 1.1 can be flashed onto your Arduino with default settings and by following the instructions on the gerbil wiki page. Thanks for the tip, LabMat. Let's cut something. Yeah, I want to cut something, but I'm kind of at a loss here. So what? Inside the gerbil xxx? Yeah. Source file and example directory. Select the zip file. Oh, what? So you wait. So you get a folder with a zip and a folder, but you're not supposed. You click add zip library, but you're not supposed to add the zip, you're supposed to add the folder because you just clicked on. Why do they include the zip? So let me get this straight. Okay. So we have, I guess this is our Dribble blah, 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 XXX folder. This is our Dribble XXX folder. And when we hit add zip library, we're not adding the zip, we're adding the folder. Okay, let's retry that. Installing the firmware on the manual? Okay, this is the point of this is the point of where we get like 3 or 4 different versions of what I'm supposed to be doing going at the same time. Again, this is we kind of hit this at every live stream. There's one version from chat that's telling me to do things one way. There's one version from the official manual that tells me to do things another way, and then there's some other guide that points me from one corner to another corner to this, and all of a sudden we have like all these things that may or may not be contradictory in the end. So let's see what the manual says. Download Arduino IDE. File open. So we open Dribble upload INO. Let's try that. File open. Let's browse through this. And you should find a file that is Dribble upload.ino, but it's not application. Why do we have an exe file here? ini h file. So there's one. We have a Dribble upload example. Yeah, sure. Is that what they want us to use? Navigate through the folders. Okay. Where's the Dribble examples upload? Okay. macOS is weird. Add zip. And then double click the zip. Okay, so we're good. We're good. Cool. So this is the one that we opened. Let's check board. Okay, so that's for the Mega. Let's just check for an Uno. We good. We're good. So USB somewhere. Uncompiling. Let's recompile for the Uno. Shouldn't make a huge difference. I will grab a longer USB cord because this one is kind of short. And you spare USB somewhere down here. One of the cameras might now flicker. Probably not. There's not a whole lot of load on the small Arduino board. So, done compiling, low memory available, stability problems may occur. Okay. Cool. So, that compiles. Let's see. Port COM8 and upload. Let's hit it. Arduino Uno, port is selected, upload, should confirm that code is done uploading, tools and open serial monitor. The following message, okay, trouble. It's now ready to go, you should start becoming comfortable with CAM. As well as find a program which will send the G-code. Okay. So, Arduino, done uploading. Yep. That looks good. So, serial monitor, we select 150 baud, we go to, yep, Dribble 1.1e. Perfect! Got it, uploaded, done. So theoretically, I feel like at this point we should be able to connect power to this guy and move some things around. BCNC, can I like not just use Pontiface? That's the tool I know how to use. Power supply. So this is a 24 volt power supply, which is nice. We have a power cord somewhere. Yeah, that looks good. We could actually just plug that straight in, but I'm gonna go with the extension cord. Don't want to trip over anything. Mill a 2D Benchy. Actually, if you guys have suggestions for what to mill, we're gonna grab a DXF file, a 2D vector file, and I'm gonna process that real quick. Yeah, come on. If you guys have any suggestions, then go ahead. I'd be open for them. So let me just see if I'll be able to do anything with Pronaface. So COM8 at 115.200 connect. That was a satisfying clunk. So let's see. I don't think we can actually see chat scrolling by. Cool. Let's see. Let's move X by 10. That sounded like a lot more than 10 millimeters, but it is what it is. It's a linear. Or it's a lead screw, so there are going to be a lot more steps than on a 3D printer. Yeah, there's a good amount of torque. There is a good amount of torque in here. Let's try the y-axis. And that is moving as well. I mean, feed rates, of course, aren't comparable to a 3D print or anything. But yeah, of course, I mean, the frame is resonating pretty heavily. I mean, it's, of course, the MDF is just gonna amplify pretty much anything you throw at it. Just noticing you could actually pop the aluminum piece off the guide rails or the guide wheels if you wanted to. All right. Star Trek logo, the Prusa logo, my logo. My logo, unfortunately, isn't all that millable. It's not. hoping that wasn't too far. It's very 3D. It doesn't really translate well to a 2D option. I could. I don't have the right bits in this size yet. I could V-carve it, but not really. What servo motors are those? Anycubic NEMA 17. So I guess let's just what do we do? So we can of course start with just some MDF. This is 10mm thick MDF. How do we clamp this down? That's going to be the other question. Usually I just screw it down somehow, but oh yeah, that is quite far down. So there are a few problems here. So first of all, this surface isn't flat. It's not flat by a long shot. So if we switch to this perspective, you may be able to see, if I don't bump the camera into the laptop screen, that right here these screws are sticking out. And here, so if I take this piece of MDF, it does get caught right there. It focuses on the one nut in the back. So it gets caught on these screw threads that poke out. Same on this side, by the way. So you can't really clamp anything down in a flat manner. I'd put like a wasteboard on here and I just screw into that, just with some regular Americans use drywall screws. I just use wood screws for that, but we don't have that. What I can try is I can put a temporary wasteboard on here, just clamp it down with some, but that's not gonna hold. That's probably not gonna hold. What to do? I think I will need a wasteboard. I think that's going to be step number 1. Just something that I can drop on. Give me a second. I'll look outside. I'll just get a small set of tools to make something. I think like particle board should be fine, maybe. Or MDF. MDF should be okay. See? So we've got some 10mm MDF. How do we clamp this down? Yeah, there is a bit. This has been standing in the basement for a while, but still good. How do we clamp this down? We could use, if we're careful, I think we can use just regular screw clamps. So let's try that. And I'm gonna get some, well, I have some screws right here. So let's combine these things into something that should work. Okay. With screws. Torx 10-bit. What do we need? Saw. We have a pencil and some tape somewhere. IKEA pen? Yeah, that's going to be good enough. About those when it comes to it. So you get down real quick. Could use the duct tape. No, I'm not going to use duct tape. Could use the CNC to plop some holes in this, some threaded holes. That's a good idea. And I think I might use that in the long run. But for now, MDF plus some clamps should do the job just fine. So let's see how I think we just need like one strip, then we can attach it. How wide is this going to be? 10, roughly 26 wide, and we should be able to clamp it down somehow. Yeah. So one strip right here. Mill the end of the screws away until it's level. Yeah. I mean, you probably know that's not a good idea. I'm gonna do this at the end of this table. Clamp, have another one of these, hopefully. Yep. 1, 2, and a square. All right, quick and dirty CNC wasteboard attaching. It doesn't get much dirtier than this. And this doesn't really hold down well, but whatever. Can't really get an eye on chat right now, but I'm sure you guys are fine. Sun is dropping. I know sound is dropping. Batteries are fine. That's just next door. It just doesn't have the range for that. Was that not deep? I set it to 15. Come on. Or did I not? I set it to 15. What? Oh, minus the track. Okay. That sucks. That's the table. At least it makes clean cuts. So there's one. Then we need 26. Okay. Quick and dirty wasteboard. So that gets clamped to our table. Watch your toes. Yeah. So this fits almost perfectly in here. Haas, I missed that. Thanks for the €5. Buy some duct tape. I'm not gonna use duct tape. Not gonna use duct tape. Come on. I've not fallen that low. So the thing is, I can't just push this stuff around by hand. I actually have to connect through software to move these. I think. Can I? No. Can definitely not push these by hand. So Y plus. Will 100 work? Let's try. Official guide uses double-sided tape. Yeah, 100 was good. Oh, that's perfect. So if I just clamp it up here, I mean, I could double-side tape it, but I've had bad experiences with double-sided tape so far. Super glue stuff together? Nah. So I'm hoping if I just drop these in here, so we should be able to mill out a small-ish YouTube logo without crashing into anything. That gives us good clearance left and right, decent. So if you mill somewhere back here, should be okay. That's going to be our workpiece or our stock. That's plenty of space left and right. I mean, I'm just going for like 2 inches, 5 centimeters of a quick logo. I will actually try to quickly make a DXF in Onshape. Yeah, so that thing is very definitely missing any way of attaching stuff to it. I mean, you give people just a flat surface with no features, no holes, no nothing. I feel like that's a bit of an oversight. Typically, I mean, you have like T-slot tables or even some threaded holes or anything to attach to. Yeah, but here it's just a whole lot of nothing. Okay, let's try a few things. Okay, let's do some ESTL CAD cam setup. So setup. Basic settings, alternative language German, yeah. Millimeters per second. I think this even has a G-code sender built in. Maybe. Not used it for a while. Last time I used it was ESTL Cam 8. Work holding options. Oh, okay. Clearance plane 5, yeah, conventional, perfect. CNC programs, no. Yes. So we are on the gerbil preset. Can we do like the gaming setup where you just see me use the mouse and and frantically click around. What did I just right click? File extension NC, whatever, text program start. As long as there's no home in here. Spindle start. Program end, also no home. Spindle stop, program end. Okay. That's all looking good. That's also looking good. Perfect. Okay. So we need something to mill. So send the machine all the way back up, left, power cycle. Yeah, but why? Come on, sign me in. There you go. We did have an untitled document that we can use for this. Let's quickly make something that looks like a YouTube logo, because I guess that was requested. So, come on. Sketch. There we go. So how do we do this? I guess it's, how do we do that super curved look? Conic, no, 3-point arc. I guess let's do a 3-point arc. But let's start out with center lines. Don't know all the hotkeys, but I do know some. So what is coincident? I. Okay. So we want to do a total height of like 40, 30, 40. Let's do 40. What does the YouTube logo even look like? Ooh, so that's a very slight curve. It's not even a curve on the top all that much. Okay. Let's just try and reproduce that ever so slightly. Did I just mute something? Don't want to mute anything. That's maybe 1. Then another curve on the side. And then we can just round these over. Okay, so that's vertical. Perfect. Make those meet. Yes, that looks okay. Total width of the thing, yeah, 50 to 55. And this one is going to be tangential. Something like this, I guess. So mirror these. And oh, same up here. So tangential, there we go. Is it? It is. Okay. So mirror these. Ah, yeah, we had the center point coincident already, so that's okay. Mirror these down. Yeah, I guess. 5, yeah. Yeah, okay. Then we add the play icon. I screwed up. I didn't. That looks okay. That looks quite okay. Okay, and now we can actually save this thing and say export as DXF. So DXF, YouTube logo. That's fine. Give me the file. Spline, yeah. Good. Where's my file? Where's my file? There we go. YouTube logo, save that, and import it into ESTL-CAM. That's millimeters, and there we go. It's looking good. So we have a part. And let's see what tools we have. So let's try and use... Actually, I like the red. It's almost like it's meant to be. So what tools do we have? We have a... this one looks good. We have a 3 flute 6mm. That might be a bit too much, but it's going to make a hell of a lot of dust. Maybe try this one. I don't want to go into the, or I don't want to start with the 2mm one. So yeah, maybe, or maybe let's do the 4. Let's do the 4mm one. This one looks okay, at least. It's not the greatest Milbit there ever was, but this one looks okay for the job. So, let's go through this setup here real quick. So, end mill 4mm. We're doing 4mm diameter. We're doing a bit more. Let's do 3mm of C, stepping, 9 degrees, plunge. Can this thing plunge? No, it cannot. So try 45. Feed rate. Any suggested feed rates from chat? Anyone want to suggest feed rates for a 4 flute 4mm cutter in MDF at probably as much as much or as high of an RPM we're gonna be able to set it. Any takers? 800. This is millimeters a second, so that will be probably a bit less than 800. 20 millimeters a second. I don't think the machine can even do this much. So yeah, let's try. Let's try 15, 25, 20. Okay, let's stick with 20 and let's see what the machine does. C plunge, yeah, 24K, yeah, whatever. We're not going to do trochoidal milling, so we don't need all of these. That's fine. Okay. So we've got part set up, tool path depth. We're going to do 10, so all the way through, or let's do 12, just to make sure we go all the way through. Start at 0, machining order automatic, so it's going to cut that last. Holding tab length, yes, please. Holding tab height full. Let's stick with 5 and maybe 3 here. That's gonna, give it a bit of 1, 2, 3, and 1 up here. So tab, so as it mills through, it doesn't like go all over the place. Doesn't come loose, and a hole right there. That's not going to be square. I mean, it's a 4mm bit, so let's go 5mm deep, and that should be good. So preview this thing. Can actually, oh, left click, okay. So we can see the plunges here. It doesn't go straight down, it goes down at a 45 degree. Let's play this. So it goes to the center position and cuts out the play logo first. Does 2 passes and then it does, okay, first plunges back here. What? Oh no, that's the holding tabs. Okay, there's 2 passes all the way around and then 2 more where it's not all the way through. Okay, cut outside of the arrow to get it pointy. Well, I guess we could, but this is traditionally on the inside. So, well, let's try. Let's see what that's going to look like. If you remove this, if you say part, go 1 around. I guess that looks okay. We do 5. I guess that looks okay. And it's the same thing. It cuts on the outside. That's a good tip. Thank you for that. It's nice and pointy. So, okay, let's file save CNC program. So YouTube logo save. Okay. We're gonna load file. And all files, YouTube logo. Got it. It's interesting that it doesn't have an estimated duration. So home is in the lower left corner right here. So that's where we're going to have to home our machine to. So that means we are going to manually home this machine right now. So let's switch back to... Oh, that's why my hotkeys aren't working, because I'm clicking the wrong window. Okay, so let's home this thing. As you can see, the collet right here is actually below our work surface, so that's going to be the first thing we do. So we raise that up. We load the bit in. Once we get it up, go. Let's walk around here. I'm not going to do dust collection for now because I think it's not going to be that much dust and it's going to be more noise. Can I lock this? Yes, I can. And it's just going to be more noise if I have the vacuum and everything going. It's not going to make that much of a difference, I think. So that is locked down. Now, the 0 position, or the lowest position, is this way. So X goes lower this way, Y goes lower this way. So our home position is going to be somewhere in this area right here. Right here. So X positive, Y positive. So somewhere down here, and then it's going to cut in this area. So let's move this thing to that position. X negative, and it should never really move past this X position. It should never really move much further left than this. We still have a bit of space here, and we only have 55 over here, so that's going to be fine. 55? I don't know how much, but a bit more than that. That's going to be okay. Yeah, not much dust. I don't know. I will try and just try it. I don't know. So this should be okay. This should be enough room. Now let's go forward a bit. There's a screw right here that we don't want to hit, but this should be as far forward as we need it. And now let's drop it down until we get the bit touching, and that's going to be our 0. Fine dust. Can we do one more? Yeah, another 10 millimeters. Sure. I mean, we will be undercutting it a bit, so I guess that should be good enough. That is almost touching. Let's maybe step it down. 1/10, another. Yeah, now it's rubbing. You can hear it. You can hear the bassy frequency coming in. So let's just say G92 X0 Y0 Z0. I don't know if Dribble is going to need spaces. Y error 20. Oh yeah, because Pronoface probe. So what is it? M114? Is that is position, right? Yeah, Paper Trick also works on these. I believe that should be okay if you say G1Z5. Hold on. G1Z5 should move 5 millimeters up. Let's just see if that actually does move 5 millimeters up. It does. Perfect. Okay. So, our zero position is set, which means we are ready to cut. I'm gonna get some hearing protection, just in case, because I'm not stupid. You guys might want to get some too. And yeah, maybe vacuum. I actually don't know where that is. Sound might be dropping out. My vacuum. There it is. Just in case. Okay, got the shop vac. Hoping I'm not gonna need it, but you never know. Okay, I might be screaming at times. Maybe, who knows? So gonna send a ton of fun powder, good for clogging up your lungs. Yeah, I nose does a bit of filtering. So, right. Why don't you change your Google logo? My thumbnail. Maybe sometime. Okay. Let's try this. So theoretically all I have to do is hit print. We've got the file loaded. I'm gonna drop on some hearing protection. Oh yeah, turn on the spindle. That is also important. All right, let's go. So you on, and it does have PID control basically. Let's try this. My G-code's not doing anything. Why is my G-code not doing anything? Load file. Estimate duration 0. That used to work better. File. Save CNC program. YouTube logo. Dot. G-code. That's all the moves you're getting, okay? Load file, YouTube logo.gcode. Still 0. Ah. We are getting moves. We are getting moves, so that's good. So theoretically, it should move. Okay, let's try it again. Just there's a fresh export. Let's see if it moves again. Should I drop it? Should I drop it down 5 millimeters? No, because the printer knows it is 5 millimeters in the air. Right. This guy on. Why are you not moving? I mean, we are getting the moves in the G code. There's G3, J, okay. Obviously, Prontoface does not really send this. What is this? This did not include a sender, right? Firmware. Use universal G-code sender. Java 7. Oh God. Manual moves still work, yes. Now if this thing will open up, I'd be happy. Let's see. We're so close. We're so close. Can I still send commands, or did the spike crash it? Nope, still works. It's just Prontoface doesn't... I think it's just Prontoface doesn't send it, because this looks like... This does look like decent G-code to me. I mean, the G3, I'm sure that's like durable specific stuff. 3D printers don't use those. Start Windows.bad jar. Question is, do I even have Java installed? Yep. Okay, I'm not gonna install Java for that. So Arcs, yeah, but at least it should. Erasing the first lines until the actual movement code. Oh, okay. Yeah, that might be an issue. Just this crap up here. That's a good point, because that sometimes causes a few issues. Okay. Let's try again. So, Java is not terrible. Yeah, it's just you live in your dream world. Oh, so many helpful tips. I can't believe it. why? Does ESTLChem have? Something? No. It's another thing? What? Oh. Right. I missed one. Nope. Change all G03 to G21, but then it would at least be doing something. It does have a few G1s here, so it at least should move to Z0. That's what I'm expecting. I'm expecting it to move to Z0 at least, or to 0.5 at the very least, or do something, move something. But it just doesn't do anything. So let's see, if we are at safe height, let's just get rid of these, whatever these are. And then we have another, then we have some more crap in parentheses. Don't need these. Okay, let's try. No move. I mean, if we try each line on its own. Okay. That's probably just temperature checks from... Here, let's uncheck that. That works. Moves work. G-code works. I don't know why I hit play, it doesn't send it. I'm not installing Java. So many helpful tips from chat.